There we go. Hello YouTube, how are we doing? Let me also turn my camera on. You guys, oops, that's bio, oops. There we go. Nah, I don't do bio, bro. I don't do bio. There's one guy I teach bio. He was like, yo, please teach me bio. I was like, okay. I hate teaching bio. Like, I go up my bio knowledge, but it's not to an extent where I'm like, yo, I'm 100% with it. Because I've forgotten a lot of this stuff. Like maths, I'm on top of. I teach maths and chem. Nah, it's not gravy, it's Frosties. Frosties on top. Banging. Oh, chill, but you can't see me on. You can't see the camera on here. I can't have two cameras on at the same time, so it's like I have to have it on one app. So come YouTube, all the TikTok guys here, come on YouTube. I'll probably be like looking at both the chats. I'll try to look at both the chats, but it's most likely going to be on YouTube ones. And I'm going to be looking at more. But yeah, are you eating craves? Give you the good news. What's the good news? The good news is grade boundaries are going to be lower. The bad news is the papers are going to be harder. You know what it is? The beasts doing 2, 3, 4 simultaneous papers at the same time, yeah. That's your competition. But I can't like they like. It's for clout. I'm gonna be real, bro. It's for clout. You cannot complete. You cannot complete a paper you have not seen under 30 minutes. It's not possible, bro. Like you need around 45 to an hour minimum. I mean, fair enough. If you can, you're not fair. Fair play. I've seen a guy do a further maths paper in 19 minutes. You cannot do a further maths paper. I can guarantee you cannot do a further maths paper in 19 minutes if you have not seen those questions or done those questions before. Like, a lot of it's for clout. Not fair, it's just revision. Fair. But yeah. Guys, if you're on TikTok, come YouTube, man. That way, you guys are you're just gonna scroll and you're gonna get distracted. Your parents are gonna ask you, why are you on TikTok? And you're like, nah, I'm revising. Let's come on YouTube. It's a mix of both. But you know what? Let's get started. We're gonna start off simple, easy, geometric sequences. It's gonna be slightly different from the last session. It's gonna have loads of parametrics still, but I'm gonna focus on a lot of the kind of other topics that we didn't cover. Like for example, geometric sequences here. I've got a logs question on the side as well. But yeah. Hot chocolate. It's a mix. We kind of go through the paper at the same time. I say attempt it first. It's a mix. If it's a difficult question, we'll walk through it. But yeah, let's start it. Like further maths students, they're a minority. Now they're a minority in the people who in the maths kind of thing. But even if further maths wasn't a separate subject, they would actually inflate your boundary. Like they would still be inflating like grade boundaries. But I think grade boundaries are going to be lower this year, anyways. 2024 papers. I don't know if you guys have seen them. You might have done them in like mocks for year 13. Like generally, they are easier compared to like the older papers. Now go on my bio. Just go to my bio. There's a link there. Yeah. Just click that, or just type it in YouTube. Studies for your tutors. Just type that, and that works. Yes, RK, how you doing, man? Further maths, you mean like further pure? Or are you talking about like literally further maths? It depends. Integration, it's okay. I think I really liked integration when I did further maths. Argand diagrams was a lot different. You have obviously Taylor series, which I actually like that quite a lot as well. Vectors is completely different. Completely different. What's YT? Studies for your tutors, Miles. So just go to my bio. Just go to my link. There's a link in my bio. I'm gonna double check if it's there. I did just update it now. Let me have a look. Let me have a look. Yeah, it is there. Just click it. Okay. I'm gonna start this question. Like, just hit a little bit here and there. I know you guys are probably trying this right now. It's not too bad. It's a nice geometric question. So we got 3 terms of a geometric series. Is it just a black screen? What's a black screen? Can you not see me? I think you can see me, right? I think you can see me, right? Oh, don't want that. Okay. Alright, yeah, calm. Alright, cool. Okay, we got 3 terms. We have k plus 4, we have k, and we have 2k minus 15. And since it's geometric, we're going to be multiplying by something. Okay. Now, in terms of what to multiply by, you can think of it in terms of fractions. So, for example, if I have, I don't know, 3, I want to get to 7 somehow. What can I multiply by? I'm going to divide by 3 times by 7. Similar concept here. I can times by k divided by k plus 4. Okay, so that dividing by the original term that we have here kind of cancels that out. And we can do the same thing on this side, on the right. 2k over 15, 2k minus 15 divided by k. Okay. Now, since it's a geometric series, yes, Muyulu, I have some stuff planned down here. That's actually not even that bad, actually. I do have some stuff planned more further down. It's like 3 hours. It's going to be 3 hours today. We're going to finish at 5. We'll have a bit of a break in between, maybe. But yeah. Now, geometric series, it's you have a constant r value, like Massini said. So what we're going to do is we're going to equate these 2 terms together. Oops. We're going to equate these 2 terms together. So that means that k over k plus 4 must equal to 2k minus 15 over k. And we're just going to rearrange. So that should get us k squared is equal to, I've just times by k by the way on both sides. I'm cross multiplying here. Like so. And then we're going to expand out. So k squared is equal to 2k squared goes there. Minus 60 will be here. And I'm just going to do a bit of inspection. I'm just going to look at the show that. So I'm going to assume this is going to be 8k, probably. No, minus 8k. No. Let me just do it actually, bro. That's 15k, 8k, minus 15 plus 8 gives you 8, minus 8. Yo, my maths is terrible. Oh my days. This is the one mental maths I can't do, you know that. What's minus 15 plus 8, guys? Minus 7. Crazy. Crazy. Let me double check if I did anything wrong there. K plus 4, yep, that's calm. And then essentially, we need to rearrange for this case, for just 0. So that ends up with k squared minus 7k minus 60 equals 0. 100% works with AQA. 110%. It's going to be slightly different in terms of the varied questions, into the question format. But maths is just maths is pure. All the knowledge transfers over. Okay, cool. And by the way, if you ever have a quadratic, you just get in the habit of just solving it straight away. Yeah. So I'm just gonna put this into my calculator, my trusty chunky calculator. I've got it on screen now as well. Last time I didn't have it on screen. I'm just gonna put it into this. To be fair, your normal calculator should also have this function anyways. So k equals 12 and k equals minus 5. But it says that k is a positive constant at the beginning, so k cannot be minus 5, k can only be 12. Okay. Cool. Yo, Pranay, don't push up the grain boundaries, man. Find the common ratio of the series. Well, we worked out K. We want to work out the R value, which is this multiplier here. We're just going to sub 12 into this. So this is going to be 12 over 16, which is 3/4 for part B. Oh, part C, sorry. This is paper 1. Just pure. To be fair, I know OCR does pure on stats. I know it's pure on stats and pure on mech. This is just paper 1. So OCR students, I'm sorry, not going to be any stats or mechanics in this. Just pure. Your part D. How did I get the common ratio? Well, we worked out K. We just sub this back into here. Okay, we just sub it because this is our R value, right? We times by R. Okay, that's our common ratio, so we just sub in 12 back into here. And 12 plus 4 is 12 over 16. Okay. For part D, see if you can work out part D real quick. Once you've got the answer for part D, just shout it out. Just put it in chat. And then we'll move on to this exponentials question on the right, and it will slightly increase the difficulty. You guys on TikTok, come to YouTube, man. Come YouTube. Oh, we got a couple different answers. We got 44, 48, 64. Let's have a look. Let's have a look. Our formula is going to be A over 1 minus R. Now A, have to be careful, is your first term, which is K plus 4 here. This is your first term. So that means our first term is going to be 16, which is just 12 plus 4. Right? Our R is 3/4. So that's going to be... Sorry, guys. 1 minus 3/4. That's the same thing as 16 over 1/4 if you put that into your calculator. That should just give you 64. Sorry, guys. Okay. Cool. Are we happy with that? Does that make sense? Am I the one doing two? Nah, I'm not the one doing 2 papers at once. I don't need to, man. Maybe if I was year 13 still, I could join the clout. But I'm too lazy to do 2 papers at once for vibes. I don't like maths that much. Okay. Cool. Are we happy with that, guys? Any questions? Any questions on that? I think we're good. Cool. Let's move on to this exponentials question here. Have a read, attempt some of it, and then we'll go through part A and B and such. I can't lie, you don't. It's a bit excessive, to be honest. They're doing it for vibes, bro. They're trying to make you worried. Just chill, relax, perform how you normally perform. And yeah, yo, my bad. I finished my cereal. I had a lesson in the morning, so I didn't really eat anything, and I woke up late. My sleep schedule was kind of fucked up. I can't lie, man. And I know your guys is as well, bro. It's not like you guys are sleeping at 9. I know you guys are sleeping at 2, 3. Okay, part A I think is pretty nice. It's a pretty nice question. What they like to do as well is they like to put this in thousands or in millions or this kind of thing, and you've got to be careful with that, because sometimes when you have these time scales, you might need to do a bit of conversion. I don't think you need to in this question, potentially. Actually, no, I take that back. You do. But anyways, for part A, it says when t is equal to 0, n is equal to 32. We're just going to sub in the numbers. So 32 is equal to 125 minus, which is going to be A, because any sort of exponential to 0 is just 1. So that means that A should be 93. Part B, You got there quick, Imran? Let's have a look. Are we happy with A is 93, yeah? Can't see the whole question. Oh, sorry, TikTok guys. Is that better for TikTok? I can make it a bit smaller for TikTok, if that helps, but I think sometimes it just clips. So if you guys are on TikTok, just come to YouTube. Okay, part B. The total sales of the phone is 100,000. Now, if you guys are unsure where to start, remember this is the key bit here. The total sales N is in thousands. What's in the power? That's a good question. I will write it out because it's a bit small, right? 125 minus AE minus 1 minus 0.109 T. Because it's just clipping for the guys on TikTok. You guys, if you're on TikTok, come to YouTube. Okay, that's the question. Oh, that's the equation. Okay, we're getting a couple different answers. We've got 14.1, we've got 12.1, we've got 11.63, 12.05. Okay. Yes, Kit, how you doing, man? 12.1. Okay, we've got 3 12.1s. I don't know the answer off the top of my head, so we'll quickly work it out. It should be 2 decimals. Yeah, 2 decimal places. Okay. Now, what we're going to set N, we're going to set N to 100, not 100,000. 100,000 is incorrect. We have to do 100 because it says it's being measured in thousands. Okay. Yes, Zach, how you did? 100 is equal to 125 minus, well, we worked out A, so I'm just going to put in 93. E to the minus 0.109 T, and we need to work out the value of T. You can just leave it like that, you don't have to put a capital T. We're going to rearrange, so this becomes minus 25 is equal to minus 93. Continue to rearrange, so this becomes 25 over 93 is equal to this. Oh, you guys can't see that. Oops. So I need like more space, but I can't have more space. It's like impossible. Should I make my webcam smaller? Okay. And then we're going to continue to rearrange, and you should end up with ln of 25, or even minus ln of 25 over 93, which is going to be, let's put that into a calculator, I believe it is 12.1, minus ln 25 over 93. Boom. The hell did I do there, bro? Oh, forgot to divide by minus. Oops. Over 0.103. So that's going to be divided by 0.109. Yeah, 12.05, guys. So, guys who got that, perfect. What's up, Bean? Why are you feeling like it's over? Are you unsure about what I did here? So I've just taken this and then I've just quickly rearranged it, that's all. Okay. So we've taken this 100, equated it, and then rearranged for the value of T. Okay, so we've done 25, so 100 minus 125 gives us minus 25. Then we're going to divide by the negative 93, which just gives this fraction. And then I've just quickly kind of done it on one step, but you can ln this and then divide it by this number afterwards, which should give you 12.05. Next week, potentially, next week's Chem. Next week will be Chem. Maybe, I'm thinking Friday, I will have a look, potentially, maybe Thursday. Okay, this is Edexcel specifically, 234. But guys on TikTok, if you want to hop over to YouTube, come over. Have a go with this. Is next week AQA Chem or a different exam board? Next week AQA, no, all chemistry. They're all on the same day. Oh, part C. Was there a part C? Did I miss it? Oh, shit. Oh, sorry, guys. I completely just missed the whole part. That's actually my bad. I don't know why the question. I thought the question was finished. Sorry, guys. That's my fault. Find according to the model the rate of the equation. Okay, so when you're talking about rate, you have to go ahead and differentiate. So when we're differentiating this, you guys are really rushing ahead. So I might speed up the pace then. dn over dt is going to equal to minus. Oh, sorry, not even minus. When we're differentiating our exponential components, it should be 125 minus 93. So this is our original equation, right? If we go ahead and differentiate this equation when we're trying to work out rate of increase, thank you for subscribing, Anya. See, I've got that notification now. I know what I mean. I know what it means now. dn over dt. Well, 125 just differentiates to 0. That's just nothing. Here, we're gonna times by the exponent. Exponent's differentiation. So that's gonna be minus 93 times by minus 0.109, because that's our coefficient, and then our e stays the same. Okay, this is essentially a bit of chain rule, and then what that looks like would be this. It should give you 10.137 e to this. But the question is asking us, what is the rate when t is equal to 7? So we sub in t equals 7, and then our answer should be 7 times by 109, which is going to be 4.73, for those who got that. Perfect, guys. This is not from Madas, this is from an international paper, but it's like very early on. Some of the questions are going to be from Madas. So yeah, we'll finish up at 5. Right now it's just a little nice start. It's definitely going to get harder, so if you're finding it easy right now, don't worry. It's going to be interesting. Let's see. Give a reason why the given equation is not suitable for modeling. Nah, Bean, I'm not staying on all day, bro. So it says the total sales of the model is expected to reach 150,000. Okay. The question itself, well, you can see the equation itself. Our equation is given 125. Now, in terms of exponents, whenever you have an e-graph, your e-graph looks like this, right? You have an asymptote at y equals 0. It never actually reaches 0, and this part just goes to infinity. But as soon as, for example, I do any sort of addition to my exponent graph, and in this case, you are right, it is decreasing. So you know what? Let's flip it around. Let's flip the graph around. Okay. As soon as you increase the number, or as soon as you add a number, which causes the graph to move up, so this is kind of linked to your transformations. As soon as we move this up to 125, our maximum point, or actually the graph wouldn't even look like that, I take that back. It would actually look more something like this. So our kind of asymptote will be y equals 125. The model is saying to us, the total sales of the mobile phone is expected to reach 150,000. And if you feel like, okay, I don't know how the graph looks like, that's completely fine. Okay, go into your calculator and sub a really large number into the equation itself. Okay, 125 minus 93, let's just put a really large number. Okay, and in this case it's going to be just negative, because we pick a really large number for our t. Okay, and you'll see this will just tend towards 125. Okay, it's never actually equal to 125, but your calculator will just round it. And you can see that here it says 150,000, so you have to say the model has plus 125 as a constant, or asymptote at 125,000. Therefore, model unsuitable, can never reach 150,000. Does that make sense? Yeah? You can think about it visually, or you can think about it in terms of putting the numbers into the equation itself. Okay, like in terms of this, of how I knew that it looks like this, the reasoning is because I kind of experimented with the e-graphs. I don't know why I did this in year 12, don't ask why. But essentially e-graphs kind of look like this. E to the minus graphs look like this. And then when you add this, it kind of flips it around into kind of like a shape like that. Yeah. So that's kind of what's going on here. And you can see that's reflected with that. But if you're unsure, just put a really large number and see what happens. Okay. Being I did get an A star. I'm studying at LSC this September for economics. So you can trust me, man. You can trust me. Okay, let's increase the difficulty. Let's increase the difficulty. Have a read of this question. Try it. Thank you very much, Miley. If you guys can do part A and part B, and part C is actually not even that bad. Part A is probably the harder bit in my opinion. Okay. Attempt it. See what sort of if you're able to get towards it. Okay. Sometimes with trig, especially with trig identity proof, a lot of it's kind of like trust the process type of thing. Okay. Hi guys on YouTube. I mean TikTok. If you're on TikTok and you guys are like, I can't see the thing, if it's too small, just hop onto YouTube. That way you're not distracted. That way you don't parents are like, yo, why are you on TikTok? Hi Saifola, how are you? Okay. Should I start it? I'm gonna give you guys 1 more minute to attempt it. And I'll kind of slowly come on from behind. Okay. If you guys have any questions in terms of like where should I start, definitely ask. Part A is not too bad. It's alright. I think it's alright. First kind of impressions to me. Is it too easy? It's too easy. Okay. We'll increase the difficulty in a second, bro. Don't worry. Yo, chill out. Crazy. Yeah, good thing I'm not a normal streamer, man. Otherwise, I would have got clipped. Okay, first impressions to me is kind of like we start with some common denominators. So I'm gonna do it like this: cos 2x cos x plus sine 2x sine x is equal to divided by sine x cos x is equal to just like that for now. If one of you, for some reason, has memorized one of the trig identities from the formula book, can anyone tell me what this could simplify to? If not, that's also fine. Nah, they're not. They're not like they're nowhere going to be near the 24. They're not. They're 100% harder than 2024. Yes, Cindy. My guy, Cindy. My guy. It is 2x minus x. It is. So the reason why you can spot that is because you have a cos and cos next to each other, and the sine next to each other. It is possible to do it without spotting that addition formula, by the way. It is possible to. You just kind of expand out the cos with its identity, expand out the sine with its identity. You can do that. Okay? But I think spotting that sort of thing is a really, really smart thing, because cos A minus B is the same thing as from the formula book. Cos A, cos B, plus sine A, sine B. And for the guys who said cos 2x minus x, absolutely right on the numerator, divided by sine x cos x. And that's why you said it's easy. But the guys who didn't spot that, it's a bit more trickier, which is fine. It's okay to do it the longer way. It's completely fine to do it the longer way. And if you were to do it the longer way, you would expand this out. You could also expand this out. What is the best way to revise from now until the exam and get grade 9 in maths? Past papers, bro. This is spam past papers. This will be cos x over sine x cos x, which is the same thing as cosec x. Amazing. Okay, for part B then, you can apply your identities. If you've got some answers in terms of radians, definitely just put them in the chat. If you jumped ahead, this will give you. I'll just sub in kind of the identity what we have from here. In part B, your part B will always link to part A in some way, especially in terms of trig. So try to spot a pattern. Okay, never ever be like, okay, I'm just gonna start expanding it out. No. Think about how does this link to this. Well, this will be cosec to theta, because you can see the x is actually no, sorry, I take that back. It's just cosec theta, because you can see all of this is basically the same as this. The x just changed to theta, and it's just got squared around it. So this is going to be just cosec squared theta is equal to 6 cot theta minus 4. That's what we are linking it together. There is actually one dot. I don't know what to call you. 1 second. Let me look at your. Yeah, I'm just going to call you dot in TikTok. I do have an parametrics down. It's not this one. It's this one here actually. This one's technically it's not ellipses, but it's linked to it. And when we get to that, I'll show you. But for now, let's continue on with this. What's the point of doing past papers though if the new questions will be different? It's because you can still see. If you finish all the past papers, then fairs. I said look at international past papers, because the whole point is you look at new stuff that you haven't done before. And especially in exam and time conditions, your environment is actually way different. That you'll find that you might, if the people who have done AS exams, you'll find that after the exam you're like, oh, I should have got that question right. It's because you clock it afterwards, because you're not in the exam situation anymore. The exam situation just it's a different environment. Okay, how does cosec link to cot? We're going to use our identity. The way I kind of remember it is this tan squared plus 1 is equal to sec squared, and then I kind of just invert it so that becomes cot squared plus 1 is equal to cosec squared. That's how I remember it. But if you're unsure in terms of how to remember the identities, you can also derive it from sine squared plus cos squared is equal to 1 by just dividing the whole equation by sine, and you can see this will give you actually the same thing as this. But yeah, that's the identity we're going to be using. Papers are going to get easier, right? No, not necessarily. If papers are going to get harder, that means grade boundaries are generally going to be easier. To 2024 paper, if you did the 2024 papers, overall they were easy. I've seen the OCR chemistry papers as well. I can't lie, it's fair that it's 90%, it's 91%. They were not hard papers. 2022 and the papers before, they were a lot harder than the 2024 ones. Yeah, 2023 it was a high grade boundaries, but honestly, they were tough papers as well, to be honest. But I think grade boundaries are going to slightly decrease for your year. Yeah, but I think papers are also going to be harder. Like the AS papers were tough. 3 hours were finishing at 5 o'clock. No man. Okay. Alright, I'm going to use the identity. I'm just going to substitute this in. So this becomes cot squared plus 1 is equal to 6 cot theta minus 4. I'm going to bring everything to one side, so this becomes a quadratic. Minus 6 cot theta plus 5 is equal to 0. Okay, now if you're unsure on what this looks like and how you can solve it, you can actually just make it a kind of a quadratic like this. Like this is absolutely acceptable. I do teach OCR Chem actually, but I think probably I'll be focusing on AQA. I know that paper 1 OCR has rates in it. Paper 1 AQA does not. But either way though, you have loads of acids and bases. You have transition metals. I'll do a bit of OCR Chem or transition metals, to be honest. You have, what else is there in terms of, you have Born-Haber cycles, Hess's law. Like that's not too bad. That's linked more or less the same thing. You have Gibbs. That's all I can think off the top of my head. Can't think of what else there is. There's probably more because it's oh yeah, there's in OCR they don't do group 7, but in AQA they do. Group 2s in both. They don't do period 3 in OCR either. But your transition metals, honestly, if you can hack transition metals, it's literally 3 marks. In my opinion, it is the easiest. Actually, not the easiest. I take that back. It's one of the easiest in terms of the understanding point of view. Because I think the way that teachers teach is like just memorize, and it is part of a bit of it is memorization. It's just inorganic. Like 99% of inorganic is just learn it. You have to memorize it. You can't do anything about it. Like physical and organic is a more skill based type of thing. And you can't really do much about that. But what you can do is try to still find patterns in terms of, you know, how does this link to equations? How does this link to my ligands? That sort of thing. But anyways, I'm going to factorize this real quick. So this becomes u minus 5, u minus 1, which is the same thing as cot theta minus 5, cot theta minus 1. Okay, and that's going to be the same thing as this equal to 0. Therefore, cot theta is equal to 5, cot theta is equal to 1. Therefore, tan theta is equal to 1 over 5, and tan theta is equal to 1. How did I go from cot to tan? I've just done a reciprocal because these two are reciprocal functions. And then I'm just going to solve for theta, where we have between 0 and pi over 2. If I just put this into my calculator, it's already, make sure in your radians, do not use gradients on your day. Basically, I seen some guy, he got some other guy's calculator and just put him in gradients, and then he was screwed, bro. So make sure you're in radians, and if you're trying to lower other grade boundaries, that's an option for you guys to do. I don't recommend it. Okay, then that means that tan to the minus 1 will be 1 over 5, which is this number here. So this is going to be 0.197. And this one here, I believe, is just pi over, I don't know off the top of my head, I'm going to be honest, pi over 4. Okay, so these are actually your only two solutions, just because it's between 0 and pi over 2. Okay, so these will be your only solutions. Gradient, apparently they use it for engineering or something, I don't know. I've never used it in my life. Yeah, so go over to your friend's calculator, yeah, or something, and be like, yeah, let me just borrow your calc real quick and just change the gradients. Where's the question from? I think this was from an international paper. Like, a lot of the questions, in my opinion, from international papers are really good. Part C, you might need a formula book for part C, to be honest. But using the result from part A, otherwise, see if you guys are able to integrate this. Have I done vectors yet? I have not. I think there is a vectors question below. I cannot remember though. It depends. International papers, there's 4. There's C1, C2, C3, and C4. C1 is like, this is PCD, that's GCSE level. C2 is at AS. C3 is going towards A level-ish, and then towards the end it gets a bit harder, and C4 is like a tiny bit of further maths. But some of the questions in international, they're good, but they're very repetitive. A limit request. What's a limit request? Perfect. Let me have a look what you sent me. Oh yeah, if you guys want to join the Discord as well, if you have any questions that you want me to look at, join the Discord. I will send a link in the YouTube chat. Give me a sec. So yeah, guys, join. Boom. I think that works. Yeah. Boom. I think that works. Let me see what you sent me on TikTok. FX. Okay, I'll look at that afterwards. Yeah. As n approaches infinity of ln, where ln equals ln, where xn over x squared plus 4. Limit. Okay, I will attempt that. I will try my best to attempt that. Okay. Part C. Did anyone try to attempt part C? Part C is just going to be, well, the integral. Amazing Bantandi. It is that. I do remember that was the answer for this. But if you guys are unsure, I will just show you how to do the integral bit. I'm not going to bother with the limits, but it is that. Oh, we've got 2 answers. Ooh. Okay, actually, you know what, let's check it. I can't remember off the top of my head if it's one of those. I will double check. We have pi over 6 and pi over 2. Well, we know that this was, at the beginning, we know it's cosec x. And we're already just multiplying it by cot x. Now, if you have something like this, go into your formula book, and I should have already brought the formula book on screen. I will bring it up real quick. One moment. Oh, this is actually really annoying. There we go. I got it. Is it minus cosec x, right? It is. I just want to show you guys in terms of what to use, because you can use both of these. You can use both of these in your these are from the formula book, and you can see that you will be using these in some way sometimes. So you can see that we have this, which is basically the same as this. Going from the differentiated form back to the normal form, you have to integrate. So this will be the same as integrating minus k cosec x cos x, which will be the same thing as minus cosec x. We're going to apply our limits, pi over 6, pi over 2. So we have essentially minus 1 over sine pi over 2, minus, then make sure you be very careful with the minus as well. So minus sine pi over 6. Okay, and if you put that into a calculator, 1 over sine pi over 2, I'm just doing my physical one so I can type it a bit quicker. This will be just, is it pi over 2 or is it pi over 4? It's pi over 4, sorry guys, oops, that's my bad. Pi over 4. That will give you root 2. Yep, so that's minus root 2. This will be minus 2, so you end up with 2 minus root 2 as your final answer. Yes, that's cosec x cot dx. Okay, and you can see that this function here, this here, if this is the differentiated form, to go from the differentiated to the normal, you have to integrate. So to go from here to our f of x, we're essentially integrating, and you can see these link together. Does that make sense? Do I think, Rico, they're going to be, compared to 2024, they're going to be way harder. Compared to your normal past papers that you do, I'm going to say they're going to be a little bit harder. In terms of like difficulty-wise, I'm going to say maybe 2023/2019. How do you know it's differentiated from? Yeah, it does, yeah. Right there. Okay. I'm going to think about what should we do. Let's do with this implicit one. I think this implicit one is interesting. Was 23 was it easy? A star. I'm saying 79. 78, yeah, 78, 79ish. Am I an undergrad student? I am not actually. I'm a gap year student going into LSE, economics, FX. Thank you, Rico, for the conversion. Oh, that's 2023. What's 79% then? 79% is 237. I think it's not. That might be a bit low. I'm saying 240. A boundary prediction. So if 79 is A star, then minus 10%, 69. Let's call it 68%. About 210. I'm gonna call it 210 for A. Okay, I think this is a really nice question. But you know what, Rico, the paper's going to be tough, bro. I think, man. I think the paper's generally going to be tough. I think mechanics and stats, in my opinion, they were piss easy last year. They were actually way too easy. They're going to make it tough this year. So even if you find pure good, I think mechanics and stats are going to be hard. Mechanics is going to be hard anyway. Mechanics was way too easy. I wish I had the paper, so I just don't. For parametrics, it other way around, Bean. Other way around. Make sure you do dy by dx. If dy by dx, you're doing dy by dt times by dt over dx. You have to make sure that these cancel out. Okay. So make sure you're just doing it in that order. It's not linked to implicit, guys, but I think he's just asking a general question. Okay, try this question. I think it's really, really interesting, and we'll start in like a bit. Mechanics, potentially, maybe, probably. Now you can get more on mechanics and stats. Now guys, don't worry about the 9 marks. Don't worry about 9 marks. It's cool, it's cool. Okay, I'm gonna start you guys off. I'm just gonna expand the brackets first. So we got x squared y minus xy squared plus 16 is equal to 0. And then we're going to differentiate. Sure. This is Edexcel. This is Edexcel live stream. Desktop. Okay. I'm on live on YouTube as well, by the way. So if you guys want to come to YouTube, come to YouTube. You guys can see me on YouTube. Yo, it's so stuffy in here. I might actually. I'm gonna open my window in a bit. It's actually way too warm. How much do I charge for a 2-day Eco crash course? You haven't started. You might be cooked, bro. You haven't started. Yo, start some past papers or something, yeah. You did, damn, 39 minutes. Crazy. That's cold. What's differentiation? You should be calm, bro. Should be alright. Okay, when we're doing implicit differentiation, these are essentially product rules. So we're going to be doing a product rule for this one and this one. And I'm going to kind of make it separately. So, I don't know if you guys like to use du by dx, or I don't really like that. I kind of just use the functions. It's kind of the same thing. Just f and f prime, g and g prime. I'm going to separate these two out as x squared and y. So my first kind of function is going to be x squared, which differentiates to 2x, and y differentiates to dy by dx. And my product rule in this case would be kind of like a cross multiplication you can do, which is kind of like this. So that's going to be x squared dy by dx plus 2xy. That's what this differentiates to. Same thing, bro. Same thing, man. Okay, and then we can apply the same thing for x minus xy squared. I'm going to do the same thing up here. A bit of product rule. We have minus x differentiates to minus 1. Y squared. Now y squared you have to be careful with. Y squared differentiates to 2y, but because we're differentiating y, you also have a dy by dx. Okay, and you can actually prove that with another product rule, but I'm not going to bother with that. Okay, so this would be, if we do a cross multiplication here, minus 2xy dy by dx minus y squared. Cool. And then, well, 16 differentiates to just nothing, so that's just 0, equals to 0. That's our differentiated form. This will come YouTube, man. Okay. Oh, Cindy, I think you're alright. I want you, Cindy, to work out the other one as well. There's technically 2. So you worked out the stationary one. I want you to work out the vertical point, kind of. It's called the vertical stationary point. Okay, once we've got this, well, the question is asking about stationary point, so chances are we probably have to rearrange for dy by dx. So let's go ahead and rearrange it for dy by dx. Oh, that's a good point, Freddie. I have not. We'll probably do that in a bit. I have not done all the international papers. When I was revising maths for A level, I was doing international further maths papers. But I would recommend you look at C3 and C4. Probably C4 I would look at. You can't do all of C4 because it has a bit of further maths. But I would recommend those two. Sine H. Bro, listen, yeah, you know what they say? Like, this is shine, cosh, tanch. It sounds so clapped to me. I just say sine H and cos H. Is there a way to find the stationary point? Not really, I'm going to be honest. Greater boundary for B, what am I predicting? I'm going to predict a 54%. Let me see what that is for a B. I'm calling 162. Oh, you're saying 165? Yeah, around there. Around there. I don't remember, I'm not going to lie, bro. In past papers, I was getting like 95 to 100%-ish. It's like the one mark I was losing. And then in my real exam, I got 94%. For A-level maths. And I know exactly where I lost my marks as well, bro. It was a large data set. 2024. But it was an easy paper though. It was an easy year. Appreciate it, guys. Appreciate it, guys. But yeah, let's rearrange for dy by dx. I'm gonna move everything that has a dy by dx to the right hand side and everything that doesn't to keep it on the left. So that's 2xy minus y squared is equal to 2xy dy by dx minus x squared dy by dx. I've just gone ahead and moved all the dy by dx terms to the right hand side. Okay. Next, what I'm going to do is your teachers have probably told you that it can act as a fraction, but it's not a fraction. So you can go ahead and then factorize the dy by dx out. So this gives you 2xy minus y squared is equal to dy by dx factorize out 2xy minus y squared. Sorry, x squared. And I'm going to divide. You might have gotten a slightly different variation. It doesn't matter. Like if you have y squared in front, as long as you kind of multiply by -1 and it gives you the same thing, that should be fine. But this should be your term for dy by dx. This is your implicit thing for this equation up here. Sorry, implicit differentiation. I would look at international papers, KP. Look at C3 and C4. Maths is really good as well. I think international papers, they can get a bit repetitive. So I would really recommend maths. But international spec will also be helpful. How does this help in life? Good question, man. It's good foundations for stats when you do a bit of calculus and stats. And then obviously stats used in trading, stats used in analysis, all sorts of stuff. All in econ. Cool. After this now, we need to work out, well, what's the stationary point of C. We're going to equate the numerator as 0. Now, essentially, what's going on is, whenever you have a graph, this is just a random line, right? Your gradient, when you're working out a stationary point, your gradient at that point is 0. Well, that's not really 0, is it? That's it. That's 0. So, essentially, when we have a fraction, how can we cause this fraction to become 0? Essentially, we need the numerator to be 0. So we're just going to do 2xy minus y squared is equal to 0. So that 2xy is equal to y squared. Actually, no, I should probably not do that. Let's just factorize out of y. Like so. And we get y equals 0 or y is equal to 2x. Yes or no? Oh, my bad. See, my bad. You can't really. You need to rearrange for dy by dx. I'm not gonna lie. Yes, this is implicit differentiation. Good. Y cannot be 0. Thank you, Milu. Y cannot be 0, so we're gonna ignore this. So that means that y is equal to 2x. Perfect. Yes, Neha, there is, and I will talk about that. There was a question like that in A-level maths actually, and I will talk about that after this. So after we've done, well, we've got y equals 2x, right? We still have not got the stationary point. That's an issue. So what I want you to do, guys, I want you to take this y equals 2x, rearrange it, and put it into... you don't even need to rearrange it, actually. Just plug it into this equation and get me a value for x and get me a value for y. Okay, get me a coordinate. I've only seen one person say the correct coordinates. So I'm going to just sub that y equals 2x in. And yeah. So we're not divided by y here, Sabo. That's the thing. So if you did divide by y, then yes, that would be incorrect. That's why I factorized it out. So either y is equal to 0 or y is equal to 2x. But in this case, y can't be equal to 0 because that's what the question has told us above. So we've just got that. Cool, x equals 2 and y equals 4. We've got that. Good, good. 2, 4, 2, 4. Any more 2, 4s? Alright. Essentially, we're just subbing in the y equals 2x into here and working that out. If you worked out 2, 4 already, I want you to think about what the graph... there is technically another stationary point. You guys have been talking about it in the chat. So essentially what the graph looks like, I'll give you a bit of a hint. Robbie, I'll just check you're working out again. Your x coordinate is right. Just check your y coordinate. The graph kind of actually looks something like this. There's a bit more to this, but it looks something, I believe, something like this. Okay, essentially, no, it's not an oval in this case. Essentially, you have 2 stationary points. There's like a bit more like down here, something goes like that, and something goes like that. This is just from memory. But essentially, you have 2 stationary points. This is the one that you worked out, 2, 4. Okay. However, you also have a stationary point up here. But the reason why it's not considered a stationary point is because the definition of a stationary point is a gradient is equal to 0. Right? We'll just keep it like that. That's what the definition of a stationary point is. However, this is from Madas maths paper. However, the gradient here is not 0. As we go ahead, and someone was asking me about this earlier, I think it was it Sabo? I think it was Nihar. It was Nihar, yeah. So as we look at this, you can see the gradient is increasing, increasing, and increasing. And eventually, as you get to this stationary point, your gradient is going to be infinity. So when you have a vertical stationary point, your gradient is going to be infinity. I wish I could tell you, I cannot remember. It is, if you want to take a screenshot of the paper of this question, I think it might be P, it might be M. I can't remember off the top of my head. It's just a bunch of questions I've just got here. So when you've got dy by dx, which is infinity, well, we need to think about, okay, if we go back to our fraction, if we will go back to our dy by dx equation, how can we make this infinity? Why is it not, okay, so if we can't do dy by dx equals 0. Oh, dx by dy. You can. Moilu, that's right, that is actually right. And this is where I'm getting to that point. Essentially, we're going to make the denominator equal to 0. Okay, because as denominator gets smaller, your fraction gets bigger, right? And you know what? I really like that. I really like the fact that dx by dy. I really like that. Are you rotating the graph? Essentially, yeah. Where do we get the 2 and the 4 from, Deborah? Essentially, we've just substituted y equals 2x into this equation here, and we work out the x and the y coordinates. You'll get a quadratic, and you can solve for 2 and 4. This part I've just made. It's not asking about the vertical point. It hasn't asked at all. Okay, I'm telling you if it does, because I've seen a question where it does. I will try to find what that is. Where does y equals 2x come from? It comes from the putting the numerator as 0. But let's go back to the point of a vertical asymptote. Sorry, a vertical stationary point. That means our gradient is going to be equal to infinity, and that means as our denominator gets really, really small, that means our fraction gets bigger. So that means as denominator approaches 0, our dy by dx has to approach infinity. Okay, so essentially we're going to set 2xy minus x squared equals 0. That's essentially what we're doing, and we can just follow the same way. Factorize out 2y minus x is equal to 0, and rearrange, where it's told us x is equal to 0 or x is equal to 2y. But obviously you can't have x equals 0 in the first bit here. Okay. How is y 4 Good question. I'm gonna call you 3 stars. Essentially, you sub this y equals 2x back into the equation here. And then sorry, I'm not laughing at you, 3 stars. There's some guy in the YouTube chat trying to make me laugh. Y equals 2x. You sub it into here, and then we're gonna rearrange for y essentially. You'll end up with 2 quadratics potentially. But yeah. Yeah, it's not funny, man. Yo, what are you guys doing, bro? Lock in. Okay. I'm gonna find that question afterwards. Let me see if I can find that. Is it called the parabola? It's like an oval parametrics. A-level question. Let me see if I can find it, because then we can. Yeah, I found it. I think it's this one. It's cut out, bro. It's not even the full question. Have you guys seen this question? The guys who have actually revised and done past papers. Have you guys seen this question before? Have you seen this? Yeah. So, essentially, you use that idea of infinity because these points are essentially vertical points, vertical asymptotes. Okay, and to work out those coordinates, essentially, you're going to use the idea of dy by dx. Yeah. So a lot of you guys have seen that, right? The guys that haven't, I've seen 2 notes that speak. Essentially, you're going to be using that idea of dy by dx is equal to infinity in this case. Okay, and if you have that, just make a note. If you have a horizontal asymptote, which will probably, actually in this case it doesn't, a horizontal stationary point. If you have a horizontal stationary point, you make numerator 0. If you have vertical stationary point, you make denominator 0. Okay. I'm gonna make a note of this. Vertical stationary point. And I doubt this will come up, by the way. I'm gonna be honest, I doubt this will come up. It's really rare, and this is the only example I've seen it in A-level maths. But there's no reason why it can't, so just be aware of it. Okay. Either way, Mayudu. You know what you said earlier, dx by dy. That's another way of doing it. That's completely fine. Okay. I like that method. a lot. So you know what, stick with it. Cool. Can we do this question? You guys want to do this question? If you guys haven't done it, or if you guys have forgotten it, you know what? Let's attempt this question then. Let's do it. What topics do I think will come up? You know what, guys, attempt it. Let's do it. Obviously integration. You have proof. I think proof will come up probably. Yo, Bean. You want to get muted, bro? You want to get muted? Take that back right now. Part B. To be fair, I think this one should be okay, just because it's not asking anything about the differentiation thing. You're not getting mod. Let me see. I don't even know how to give it, bro. Like, honestly, I'm new to all of this. Let me see if I can give you it. Can I do set notation trick proof? We had a bit of trick proof earlier. Oh, there we go. And Rico's OG though. So yeah, man. Arif's not here today. Okay. I think these two, part A and part B, is not that bad. Essentially, we're just adding them together, and probably we're going to be using our formula book identity here. Can we do a trig substitution question? Shri, you will never ever have to make your own trig sub. Just because, yes, Anya, you will. You will never ever have to use your own trig substitution. They will always give you a trig substitution. I did see one recently on TikTok. I will see if I can find that. Is it Reeves at school? No way, Reeves at school. No way. Oh, fair, fair. Okay. Yeah, we're going to be using our addition formula here. So cos A plus B is equal to... I'll put the identity here for the guys that haven't got it memorized, which is absolutely fine. It's just that a lot of sweats got it memorized. Yeah, so that's your identity. Do I do physics? Hell nah, bro. Hell nah. I do. I'll teach you mechanics though. I'm good at mechanics, kind of, from what I can remember. Yo, I remember in my GCSEs, I was so bad. I was so bad at electricity. I did not know what was going on with that. Nope, Ethan. Nope. I put down this whiteboard rubber. So I put it down. That tan identity is not coming up. Yeah, after this question, let's do this one. Let's do trig modeling. Because you guys wanted to do this question, so let's finish off this question. I'm just gonna expand our x with the trig identity, so this becomes 4 cos. Actually no. 4 cos t, cos pi over 6, minus 4 sine t, sine pi over 6. You're gonna send me one of the worst answers questions. Okay, calm. And then expand that out. So this becomes, well, cos pi over 6. Yo, Bean, you know why the tripod's in the back? Because of my recording stuff, that's why. Minus sine pi over 6 is just 2 sine t. Let me see if I've done anything wrong there. Yeah, so that means that x is equal to 2 root 3. That should be cos t, by the way. Cos t minus y. So that means x plus y is equal to 2 root 3 cos t. Pretty simple. It's not that bad. How do you do part B? Show that the Cartesian equation of C is that. Let's see. But we worked out x plus y. I would probably just kind of expand this out, to be honest. So we know that x plus y squared must equal to 2 root 3 cos t squared. And then I would also expand out, well, you have y squared as well, so I would also square y, just because y squared is here. So y squared is equal to 4 sine squared t. And then if you add them together, that's a cos squared t plus sine squared t. That should give you some constant. Yeah, so you have x plus y all squared is equal to, what's 2 root 3 all squared? I'm just going to use my calculator. 2 root 3 squared. 12. That gives you 12 plus, yeah, equals to 12 cos squared t. Y squared, you know, is 4 sine squared t. But in terms of an identity, you want, you know, the coefficients have to be the same. So I'm just going to multiply by 3 to make this 12 sine squared t. And that just gives me the fact that x plus y all squared plus 3y squared must equal to 12. Calm? Calm. Yeah, that's what I got as well. Any questions on that? Or did that make sense in terms of how I went about that? Because we have a sine squared t, we have a cos squared t. Chances are, yeah, of course, chances are we're probably going to be using our identity. Sine squared plus cos squared. Yeah, for the guys on TikTok, if you want to come on YouTube, because I know TikTok really, I've had this issue like a lot of times, and I can't really fix it, to be honest. It just clips from the side, so the question just sometimes gets cut off. And the guys on YouTube can't see it because my face is in the way. Let me make my cam smaller. There we go. You looked away for a second, Ayub. Damn. That's maths. Imagine the guys that are doing papers in 19 minutes. Yes, this is Edexcel, but it applies to all your different pure subjects as well. Okay, cool. Yes, Lewis, it is. I will be uploading it. Okay, cool. Do you guys want to do functions? I'm gonna skip functions. I'm gonna skip it. Let's do this one here. This one I'd say is more trig identity than differentiation. I think that's the harder bit. And also, Rico, send me that question you were talking about. Or is this one? I've seen this one. I'm gonna ping you real quick. Were you talking about this one? I think I've seen it somewhere. International. Okay, yeah, calm. When will I do A-level stats? Probably next week. Probably the end of next week. I don't know. Actually, no, because paper 3 is quite far. That's the thing. So I'll see. It really depends on how paper 1 goes. If paper 1 goes really bad, then I'm gonna do maybe some more pure. But yeah. Okay. Well, it says dy by dx, so chances are we're probably going to be using quotient rule with this. I'll say start with quotient rule. Quotient. Okay. This is how I have quotient rule memorized. F prime g minus fg prime over g squared. You have it in your formula book, but I can't lie. The people who use like u dv over dx and that's all that blah blah blah. I don't like that. This is how I have it memorized. Okay, sub the numbers in. I think, in my opinion, the harder part will be to convert it into the form they're actually looking for. Okay, I think the differentiation bit is actually not that bad. But let's see where this takes us. Okay, and it's kind of being able to kind of train yourself to be able to see some of that kind of stuff. Okay, I'm going to write f here, f prime, g prime, and well, f is just 2 plus 3 sine x. Being able to do differentiation in your head quick, especially in terms of trig, I don't think the trig differentiation here is hard, but being able to do it quickly is just a bonus. With scale factors, I don't think so. Send that. G is going to be cos x plus sin x, and then if you differentiate this becomes minus sin x plus cos x, which I'm just going to write as cos x minus sin x. Okay, just to make it look nice. Calm, Fred. And then essentially we're going to substitute into our equation. What do you mean, Rico? What do you mean, Bean? You don't get it? You don't get what I did? Oh, scale factors. Send it to me, and then we'll look at that. I want to actually see what you mean by that. Okay, and then we're just essentially going to substitute the numbers in. So we end up with f prime g, which is going to be 3 cos x. I'm going to write a bit small here. Cos x, actually no. Let me move this out of the way. 3 cos x multiplied by cos x sin x, cos x plus sin x, minus this here, divided by our cos x plus sin x all squared. Okay, now we need to clean this up, because that's dy by dx. It is, but we need to clean it up. I will have a look. Oh, I think Arib was doing this yesterday. I think he was doing this yesterday. He sent me a snap. Where's that from though? Is that international paper? Or is that mock set? No, you can't send it. You can't send pictures in YouTube. Or locked at Excel. Crazy. Fair. That's actually mad. Okay, I'm gonna expand this out. So this becomes the following. And this is kind of the form we want as well. I'm gonna take a screenshot of this and then move it down. So this becomes this. And the following. 3 cos squared x plus 3 cos x sine x. We need to expand these brackets out. I don't know how you guys expand your brackets out, but personally I like to use the grid method. So this is going to be 2 plus 3 sine x. That's going to be cos x minus sine x. And I kind of multiply this out. 3 sine x cos x. If you knew all this and the derivative right, but you got the equations mixed up, 2 marks. Maybe even 1. If you get the derivatives in the wrong order, you're cooked. I can't lie, bro. This is all of this is 1 mark. Substituting is 1 mark. Maybe 2 marks. But yeah. Minus 3 sine squared x. And then I'm going to substitute the numbers in. So that's going to become plus. Sorry, no, not plus. Minus, and I'm going to substitute everything in. So I've got 2 cos x here. Minus 2 sine x. Let me check if I expanded out correctly. Yeah. Plus 3 sine x cos x. Minus 3 sine x. 3 sine squared x. All divided by cos x plus sine x all squared. Looks like a beast. It looks like a beast. Yes, Arib, how are you, man? How are you? Here's a hard question, but you know what? We need to clean it up. Okay, it's really about a bit of it is to kind of trust the process. We've expanded out the brackets. Let's see what happens. Okay. Well, first of all, let's just distribute the minus that we have. Okay, and I'm gonna write the next bit in orange. So this becomes minus 2 cos x plus 2 sine x minus 3 sine x cos x plus 3 sine squared x all over cos. I'm actually going to expand out the denominator as well. So this becomes the following. Okay. Let's clean some stuff up. Yes, Tom. Tom, this is the original question, by the way. If you want to take a screenshot of that real quick. Okay. Now, this is the form we're looking for, right? I'm going to keep moving this down. This is what we need to make it into. And you can see it looks like a lot right now. But we can start to cancel some stuff out. Well, boom, boom. That goes. This and this. Well, this is an identity we know. So this makes 3 minus 2 cos x plus 2 sin x. And the denominator, I'm just going to keep the same for now. Okay, that's as much as we can get cleaned up right now. Yeah? Okay. Next, we also have something else here. Boom. Boom. That goes to 1. Bean make sure this squared. 3 cos squared plus 3 sine squared. So there we go. That's as much as it's going to get cleaned up. Okay, we're close now. We're actually pretty close. Now we need to think about what can we do from here to get to here. Why would you expand it? Something with the bottom half you're going to have to cancel. It's because it's a cos x plus sine squared. It's not a cos minus. It's not cos minus, that's why it's a cos plus. If it was a cos plus, then yeah, 100% skip. Sorry, if it was cos minus, you can do the cos 2x identity. But since it's a cos plus, you have to expand out. Okay. Sorry, that's probably my handwriting. Yes, Fred, that is actually the way to do it. Absolutely right. We're going to divide the numerator by cos, and we're also going to divide the denominator by cos. So we're going to essentially times it by the following. 1 over cos all over 1 over cos. So you can see that this 1 becomes a sec. This will just become 2 sine x. Amazing. And if you're feeling like, okay, how can I spot this? Well, just think about what have you done from here to get to the denominator. You've just divided by cos. Right? And a lot of the times, actually just converting your sec x into just 1 over cos x can make it a little bit more easier to spot. From here to here, you've just divided by cos. And we're going to apply the same thing on the numerator. Well, this is going to be 3 over cos, which is just 3 sec x. Minus 2 cos x divided by cos x is just minus 2. I'm going to put that on the end. 2 sine x over cos x is just 2 tan x. And that is our final answer. Dy by dx is equal to that in the form that they wanted. Now, a lot of it was tough. 3 they do cancel because this is a minus. This is a plus 3. You can see it is a plus 3 as well here, but there's a minus. Remember, we're subtracting, so you have to distribute the minus out. Okay. It's keen to make sure you distribute the minus out carefully, and that's why I put big brackets every time you have an expression like that. Just put big brackets around it so your minus gets distributed out. A lot of people make this mistake. Just be careful. This is just me expanding out double brackets, Tom. This is just me expanding out double brackets. I just use a grid method to expand it out, but you can use FOIL. I know loads of people do it like this as well. That works. Where did I get minus 2 from? It's because minus 2 cos x divided by cos x is just minus 2. And I've just put that on the end. Thank you, Bede. Thank you, Bede. You're beautiful as well. Okay, cool. Let's pull up the question that Rico sent me. Guys, join the Discord. Join the Discord, man. It's our questions now, yeah. Okay. I've got it's not triple, it's double. And actually, technically it's triple. I've got a monitor in front of me, monitor on the right, and then my tablet which I'm writing on. So I write on this. My pen. Okay. Let's have a look. What are you guys sitting in the chat, bro? What is that? You guys got triple integration. It's crazy. Okay. Let's have a look. I'm gonna have to read this. I'm gonna have to do this myself actually first, you know. Okay. It's a... No, I don't play LC. It's like a wire. Essentially, it's connected to the back of my graphics card. And then there's a... It's like a dual cable, kind of. Mostly I tune it, to be honest. Sabo, I would recommend you get a touchscreen laptop. Or an iPad. Just because the tablet is... This is a pricey tablet, to be honest. I bought it like, I don't know, four years ago. I was used to like do a bit of graphic design. And I was like, okay, let me just get a tablet, and I bought it. And I just never ever used it. And then I started doing tuition, and then I was like, okay, this is cool. Apprenticeships, they're good, but you'll find that they are going to be full-time. Internships, most of the time they're going to be uni stuff. Now, tablet is really good. Honestly, it's really, really good, because if you're writing with the mouse, this is me writing with the mouse. A, B, C, D, it's just long, bro. And then this is me writing with the pen. And you can see the difference. And it's smooth, it's clear. Nah, not every day. I'm going to LSE Bean. Courses, I did mostly, honestly, in my gap year, I've done mostly tuition. I'm not gonna lie. But I have learned a bit of stuff. To be honest, at the start of the year, don't ask why. I was like, yo, I'm gonna learn a bit of programming. So I was trying to make a Roblox game. Never actually made it, but I learned Lua script. So that allowed me. Honestly, I was like so dead at scripting, like coding in general. But I think it's just allowed me to even get myself into coding in the first place. In some way. So I'm trying to like potentially learn C++ or something in the future. Maybe for like in terms of AI or that kind of thing. Boom. Calm. That's sick. Go to QMO for econ or take a gap year. Why'd you not get KCL? If you got QMO, why'd you not get KCL? What did KCL want? Now don't do pure HTML. Pure HTML is ass. Don't do that. Use proper like I made a website actually. You know what I'm gonna show you right now, guys. This was like a while back. Yo, kinda it's tough website, bro. It's tough. Cold. But yeah. This was the plan. Like a while back, but yeah. Don't use pure HTML, bro. Try to make it visual as you can. An experiment. Honestly, in the gap year, you have so much stuff to experiment with. I want to tell you guys a story about my sales job. Am I gonna do the question? That's a good question, Myra. That's a good question. Okay. Let me read the question. Okay. Because Rico sent me this, so I haven't actually read it out. Okay, we got a cone. Inverted cone. Cone has internal base of 2.5. Vertical height of 4. Okay, so modeled at leaking at a rate. So this is the same thing as volume over time. So if you units that can actually help you a lot. So I'm gonna say that dV over dt here is equal to pi, or in fact minus pi over 512. So I'm just gonna make a note of this. What else have we got? Sorry guys, my handwriting's bad. I'm going to go ahead and just rewrite this as volume is equal to 1/3 pi r squared height. Eventually I'm going to try to differentiate this. Show that while the water is leaking, h3 over 2 dh over dt is equal to that. Okay, it's asking for dh over dt. I have dv, so I'm going to try to kind of work in this sort of format. So that should be dv there. Okay. I have dv over dt, which I can plug in. I need dv over dh, which could be this. I'm just trying to see if there's any more information in terms of dv over dh. Is further mass in gap year worth it? It's up to you. Why have I done my minus pi? It's because it's decreasing. If it's leaking out a hole from the bottom, your volume is decreasing. So that's why I've done minus pi. Should you do further maths in your gap year and apply to Oxford? Should you keep UCL? Further maths, it's up to you. I'm not going to say yes and no. The thing is with further is that with a lot of unis, especially in terms of maths, they want it done all at the same time. You got RM4 as max height. What do you use it for? Okay, let's have a look. Our full volume is obviously that. Have you got any volume inside going in? No, we don't. That's okay. This actually, okay, so this is actually, oh, I understand why it's used as a scale factor. Okay, so essentially, if our original volume, our original height is 4, right, and we have essentially a smaller cone inside here, we are doing some sort of scale factor from 4 to get to h, which is essentially just h over 4, right? And you might remember from GCSE, that's your length scale factor. Not 4 minus h, it's a multiplication. So, we can also apply that onto our radius that means that this radius here of our smaller cone is going to be 2.5 times by h over 4, which is, I don't know what the hell that is. Let me put into my calculator. 5 over 8h. So that is actually our radius of the small cone. And I'm actually, instead of writing radius squared here, I'm going to write 5 over 8h squared multiplied by h. And now I've got all my terms, well, my volume formula here of my smaller cone. I don't care about my bigger cone. I care about the smaller cone here. In terms of h, I can expand that out and work out dv over dh. That's what I've gotten so far. Does anyone have any questions on that? Let me look on TikTok as well. Do you do this for every cone question? Not necessarily, to be honest. Why is the square root h in the denominator and not the numerator? Oh, good question. That's a very good question. That's my bad. Yep, absolutely right. That should be in the... Yep. Sorry, F. That's absolutely right. Yes, this is rates of change, yes. Yes, you're right. Okay, I'm mostly looking on the YouTube chat as well, so the TikTok chat is kind of in the background. If you guys want to come to YouTube, I'm basically answering every question there. So yeah. How do you know when it's scale factor? It's... 1, because Rico said it. 2, 2 is because of similar shapes. Okay, if you ever have similar shapes and you're like, okay, how can I link the information? Because that's what you said, Mailu. You had the 4 at the top here. Why have they given you some information for no reason? Like, you're going to be using it in some way. Okay, so how can this 4 be linked to the height here? The only way it's going to be linked is in terms of a scale factor. Okay, and remember as well, there's no reason why they can't ask you in terms of area scale factor and volume scale factor. To be honest, in calculus, they probably won't be asking you about this because that's to do with more differentiation and integration topics. But definitely LSF. Okay, cool. I'm gonna expand this out now, so you can actually finish the question. So this is gonna end up with the following: 5 over 24 pi h cubed. So that's my volume formula. And if I differentiate this, this will give me 5 over 8 pi h squared. Shri, nah, just join my Discord. That's his team. There you go, just join that. Okay. Yo, what are you guys talking about? Battle Royale, I mean Clash Royale. Clash. I used to play this back in the day, you know. I was so ass at it. Yeah, I played Dragon City. That's my game, bro. That's my game. Anyways, back on topic. What are we doing again? We're subbing this into here because we already worked out dv over dh. We already have dv over dt from the original question. And this will give me the following. 5 over 8 pi h squared times by minus pi over 512 root h. This is the same thing as minus, I don't know, I'm going to just put that in my calculator. 5 over 8 times by minus 1 over 512. That gives me a weird number, but we'll go with it. Minus 5 over 4096 pi h to the 3 over 2. And that's equal to dv over dh. Sorry, that's equal to dh over dt. I'm just trying to see where they got minus 1 over 200 from. Yeah, dh over d. Dh over dv? Did I do something wrong? What did I do wrong? dh over dv. dh over dv. 1 second. dh over dv. Where? Oh yeah, sorry. You're absolutely right. Yep. That's my bad. Let me redo that. Yep. Oops. Absolutely right. That's a silly mistake. I don't know why I didn't notice that. But what the heck is this? What is this? What the heck is that? Yo. No, that's my bad. That's my bad. That's my bad. My bad. My bad. My bad. DH over dv times by dv over dt. There we go. There we go. Yeah. Boom. Boom. Yo, Rico, don't violate. Don't violate. Ah. Okay. Alright, and then dh over dv. Yep, there we go. Now that works. That works. Times by dv over dt. That was the same thing. I was basically doing the same thing. Come on, guys. And that's still the same answer though. That's what minus 5 over. But I'm still a bit. Right, that's pi squared. H to the. Oh, that's h squared times by h to the 1/2, which is going to be h5 over 2. Ah, that's what I did wrong. Is equal to dh over dt. Okay, cool. Alright, now I've got this equation here. Pi should cancel out. Are the pi's cancelling out? Let me see what I did. Why do the pi's cancel out? Maybe the pi's do cancel out. dv over dt. Yep, it does, because this is gonna be flipped. Yep, absolutely right. Another mistake. That's a lie, man. A lie. It's alright. It happens. So that is gonna be 8 over 5 pi h squared. Yes, and yeah, absolutely right. Whoever said pi's cancelled out, smart guy, genius. 1 over minus 512. That goes to minus 1320. That looks better. That looks a lot better. And then we have root h divided by h squared, which is the same thing as h to the minus 1 over h. Sorry, a half minus 2. Which gives us h to the minus 5 over 2 is equal to dh over dt. There we go. That looks a lot better. Okay. There we go. Boom. Nice. Alright, we're happy with that, yeah? Cool. Yo, allow it, Bean. How do you know that dv over dt is because of this? It's because of the units. Look at the units, and honestly, no, it's especially in chem as well. Actually, if you're ever worried about like in terms of density, units actually give you a lot of information. Okay, so this just essentially means meters cubed divided by, well, second to the minus 1. It's the same thing as meters cubed divided by seconds. Meters cubed is volume, seconds is time, so that has to be dv over dt. Okay, but to be fair, it does say rate, rate of and water. But yeah, scale factor thing. Of course, if we know that the original height of the cone is 4, the smaller cone inside is h. They're linked in some way because it's a similar shape. Okay, if they're a similar shape, the only thing that links them together is going to be a scale factor. How do we go from 4 to h? Well, we're going to divide by 4 and then multiply by h. Yeah, of course. The question's not finished yet though, but of course. Let me look at what's going on TikTok. There we go. Alright, let's continue on. Well, we worked out dh over dt, but at the moment you can see that, well, we've got h3 over 2 in front of it. So I'm actually going to times by h3 over 2 on both sides and see what that kind of takes us to. So h3 over 2, I'm gonna swap this around because I don't like how it's written. I'm gonna put dh over dt on the left side. There we go. It is a bit of a joke, to be honest, but some of them are doing it legit. Oh no, it crashed. Maybe there's too much writing on the paper. One sec. There we go. It's back. dh over dt. You'll donate. You did donate 10 quid. Come on. I don't want your money, man. It's alright. Don't worry, bro. This is literally for you guys. I'm gonna times by h to the 3 over 2 on both sides. Why? It's just there, so I'm just gonna see what happens. So if I do that, h3 over 2 dh over dt must equal to minus 1 over 320 times by h to the minus half. I don't know how you donate, man. I haven't even set it up. Let me look at what you said, Robbie. Should have 8 squared over 5 squared pi h. Should I? Oh yeah, I should. I should. I should. Guys, you can see my masses. It's absolutely stunning. No, no, no. It's because of this. It's because of this. Um, yeah, this part, there was a small mistake here. This should be 1/3 pi times by 25 over 64 h cubed. I forgot to square this number here. I just did the h squared. Yeah. Yeah, re-screenshot that. That's a small mistake. We can fix that though. That just goes to the following of, let me fix that. 25 over 64 with 64 times 3, that gives you this number here. H cubed, or pi h cubed. It's not going to be pi squared though. The pi doesn't get squared, it's just that. Okay, and then this will go to, as a dv over dh, that just remains the same as that. Okay, and I'm just going to change the numbers here. This goes to 192 and this goes to 25. Okay. I'm going to clear this part. This is differential equations. It's from a locked Edexcel. So Rico sent this to me. I will have a quick look over if there's any sort of mistakes I've made again, just so that it doesn't happen again. Give me a second. 1/3 pi 25 over 64 h cubed. Yep, that's calm. dv over dh. We're gonna flip this around. That becomes 192 over that. Okay, cool. So we have 1 minus 1/2 minus 3. That's still cool. That's going to be 192 over 25 times 10 minus 512 h to the minus 5 over 2. And that simplifies to the following. Which is nice. Minus 3 over 200, which is looking a lot better now. Which is this. I'm going to check what this number says here. Okay. Alright. I'm going to times by h to the 3 over 2 on both sides. This gives me minus 3 over 200. H to the minus half is equal to dh over dt h 3 over 2. That's that should probably be minus 1 actually even. I will double check this. Minus 1, 3 over 2. Yeah. Well, do we have any sort of equation for h? We have a volume equation. We have a dv over dh equation. Essentially, yeah, I'm thinking about it because we have a minus 3 over 200. That's what I'm thinking about. So I'm just going to double check if there's any sort of thing that's kind of maybe this is supposed to be minus 3 over 2. I'm just checking. Give me a sec. Volume is equal to 1/3 5 over 8 h. I'm going to check the radius thing again. 2.4 divided by 2.5 divided by 4. That gives us 5 over 8. Yep. That is fine. That's also fine. That means that's fine. I mean that's fine. Flip. That becomes that. d over dt, that's that. Yeah. So this is fine. It's just being able to go ahead and then change this part here. H 1/2 minus 3. You think I differentiate dh by dt wrong? I didn't differentiate dh by dt. You mean this? Potentially. Oh, you're right. You're right. I didn't differentiate it at all. I didn't differentiate it at all. So that becomes 25 over 192 times by 3. That becomes that. And that becomes a squared. You're absolutely right. No, you're right. You're right. It's because, yeah, so we've got this volume formula here. That's just the volume formula. That's just a bit of unclarity. So this is just supposed to remain as that. And when we're differentiating, the power will go down by 1, and we're going to multiply by 3. And then we've got this, so this part, this part changes. And this number, if we check now, 64 over 25 times by minus 512, does give us this. And this actually becomes minus 3 over 2. Shit. So you know what that's part A done. You know, we got there in the end. We got there. Okay, quick recap of what's happened. Okay, we worked out the volume formula by using the scale factor. Then we actually differentiate it correctly, so it becomes a h squared. Okay, h cubed will go to h squared, and your coefficient should be 25 over 64. You're given dv over dt in the question here. You have dh over dv as well, and we're going to be multiplying the dv's out, so they cancel out. And we have root h in the numerator, and we have h squared on the denominator. A half minus 2 should just give you minus 3 over 2. And this should just simplify to the following. This should be a 1. I didn't change that from before. And then we're going to multiply by h to the 3 over 2 on both sides. So this gives us that. Got there in the end. But that's the reality of doing a maths paper question that you haven't seen before. That's honestly the reality of it. You're going to go through a question and you're going to find that sometimes you don't get it, which is fine. Okay. The main key bit is, if it's not working, go back in your working and check, where have I gone wrong, why have I gone wrong. And a lot of the times, sometimes it's unclear, and that's fine. And if you feel like you want more paper, you can ask for more paper. Ask for more paper and redo the question. Clarity is key. Okay, if you don't know what's going on in your own working out, I will check, Shri. If you don't know what's going on, redo the question. Shri, you did not send me anything. You send it in general. Yeah, send it to general. Okay. Part B and C, I'm not gonna bother with, but you would probably just integrate. This is probably the easier bit, to be honest. And part C is actually not that bad. Okay. The reason why I'm not doing it is just on terms of time. To be fair, we do have an hour. But if there's anything you guys want to do specifically, that's... Or we can do it harmonics. You guys want to look at R sin X? This is actually not even that bad. We can even look at that. Or let's do this one. Let's actually do this one first. And then we'll look at harmonics. Okay, guys. We're going to have a 5-minute break. I'm going to go to the toilet real quick. 5-minute break. We'll be back. Yeah. Yo, verify. Click verify, Sri. You see that verify button? Verify there and then do that. Alright, I'm gonna be back, guys. 5 minutes. You guys want to do parametric as well on TikTok? If you guys are on TikTok, come to YouTube. I'll be back. Hi guys, I'm back. Yo, yesterday I was in the football tournament. Let me send it. I don't know if it let me send it here in the TikTok. I put it in the TikTok chat, but it's clickable in the YouTube. I was in the football tournament yesterday, and I played goalkeeper. My ass hurts, bro. My ass actually hurts. Yeah, let's not talk about who won, Jack. Let's not talk about who won. It's the. One sec, Shree. One sec. If nothing's happened, it says you're verified, I think. Wait. Let me try fix your thing, Shree. What's your Discord username called? Because Anya's just joined. There's the Raz. That's all I see. Unless. Tell us about my sales thing. Oh, you guys want to hear about my sales thing? Okay, so basically after A levels, right? I was like, okay, I need a job. I need a job ASAP. And so, okay, yeah, do that. I'll resend the link actually. Maybe it's something to do with the link. And essentially, I was applying onto loads of jobs on Indeed, and at one point, everyone was just rejecting me, bro. As the Morrisons, they were like, "Oh, you don't have enough experience." Actually, no, they weren't even replying to me. They just ignored me. Like, what am I supposed to do? But to be honest, I was looking for a part-time, and all these jobs, you get a job if you're able to give the hours. Obviously, I didn't want to work 12-hour shifts, but that's what it is in terms of that. So, the sales company, they called me up on Indeed, from Indeed, like, oh, you guys applied to our company, and I applied to 100, and I didn't even know who it was, and they were like, oh, we're blah 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 company, and then they invite me to an interview. I was like, sick, I'm gonna go. I put on a suit, nice, went in, it was a nice group interview, smashed it, and then they called me on an online interview, so I was talking to I think she was the owner or something, and essentially, she was like to me, oh, you're in. I'm like, what? She's like, you're in, you're starting Monday. I'm like, fairs. And then I go in on Monday the next week, and then she's like to me, so you're going to do training for 3 days, not getting paid. But she didn't even say anything about payment. She said, you're not getting paid, you're going to get paid in 2 weeks. So I thought this was normal, bro. I thought this was normal. And then this sales job essentially was, we were learning scripts to get people to knock on people's doors, so we can ask for charity. And if you get them to get on a monthly subscription for charity, I get £50 commission. Now at the time they gassed it up with £50 commission, but yeah, getting people to actually get on a monthly subscription for charity is crazy. It's hard. It's not easy. I mean, I did get some sales actually, but it was broski. I was waking up at 10, and it was all commission based. There was no fixed pay. And then I used to get home at 11 p.m. on the bus. It was so long. And then I just left it after a week, can't lie, man. I left that. What's my favourite scran? It depends, bro. It depends on my mood. I'm a dessert guy mainly, but I like savoury as well. I do drive now, yes. I do drive. Get your driving license, guys. Get your driving license. I got paid for the sales I got. I think I made 4 sales. So on Thursday, it was a Thursday basically of that week, that same week, and there were 5 man that joined with me, and then the second day in, 2 man already left, and I'm like, where'd they go? And then I asked them oh, there's something about tax issues or something, and then at the end of it, it's just me and 2 other guys left. By the end of it, I mean that's Friday. Even no, that's Monday. I skipped Friday because I just didn't want to go Friday. Saturday, I didn't want to go Saturday. Told them, yo, I'm not coming. I wanted to do this part time, and they're like, no, you have to do it full time right now. And then I went on Monday. There's 3 man left, and I do the job. I think I started the actual work on Wednesday or Thursday, something like that. But I started the work next Monday, and I was like, yeah, I just made my mind up. I'm leaving tomorrow. I got a sale that Monday, and then the Tuesday I got 2 sales that day, and I was lucky because there was an observer guy that came in, that he was observing to work. So he was just my mentor was helping him out, and I was on my own. So yeah, I was like, I made 2 sales, got my money, and left. I think that's you, Shri. That's calm. That's calm. Remote internship. It's if you can get it, then do it. Honestly, do some work experiences. Look around. No, Daniel, I've finished my A levels. I'm in gap year. I'm starting university in September. So yeah, I'm helping you guys out. Just smash your A levels this year. Be all the 2 paper, 3 paper warriors. Okay. All right, let's start this. Let's start this question. Is everyone back? Because I know I said 5-minute break. Let's give it 2 more minutes and then we'll start this. If you want to start it as well, you can. And the DI method is really good. I do recommend it. However, I was looking at the DI method in terms of mark scheme. Honestly, I could not remember anything about. No, sorry, I could not find anything about in terms of if it's valid in terms of mark scheme. Zach, you know what it is? Nobody actually cares about your education grades, bro. I'm gonna be honest, bro. No one actually cares. If you can give them hours, that's all they care about, bro. Go to ASDA, tell them I'm willing to work 12-hour shift. Then they kind of be like, calm, get on. If you tell them, yo, I have A-level maths A-star, they don't care, bro. They actually don't care. Yeah, you're right with that. If you make a mistake with that, you lose all the marks. But I'm saying I couldn't find anything in terms of that's 100% accurate on the fact that, okay, this is alternate. It's an alternative way to integration by parts, because technically DI method is integration by parts. No, don't DI is when parts infinite. Yeah, essentially. Yeah. But eventually it will converge. It will like stop at one point. So if you're running out of time, I would recommend use a DI method. Okay, just it's a quick way. So D, essentially what it is, you pick 2 terms. You have 2 kind of parts here. You might have heard of ILATE. I can't remember what it stands for. Honestly, I cannot remember. But I know there's logs in there and exponentials in there. Essentially, the one that differentiates to 0, it's going to be it's a part that's differentiating, and the other part you will be integrating. Okay, so you can see x squared here goes ahead and differentiates to 0. So x squared, then 2x, then 2, then 0. That's what I'm going to be differentiating. And my other term, e to the x, it just integrates to e to the x. So there we go. And on the side, you're going to put plus, minus, and then you're going to kind of go across like that. Only do this if you are running out of time. Fanta, honestly, I don't know. I wish I was an examiner. I wish I could probably properly tell you. I have not seen anything, even in the notes. Even in the notes, I haven't seen anything like that. Maybe in the 2024 it's changed, or the 2023. But I have not seen anything in terms of the DI method, even in notes. I was looking through it for a very long time, and I couldn't find anything that proved to me. If anyone can, that'd be great. But yeah, e to the x does differentiate e to the x as well, Bean. But the thing is, e to the x just differentiates infinitely, and same with integration, it just keeps on doing it infinitely. So you need to pick one that goes ahead and differentiates to 0, so it stops. Okay. In GCSE Maths, why are the questions similar? Like, why don't the exam board make a couple new questions every year? It's because they're limited to the spec. They can only examine you up to a specific difficulty. Like in terms of A level, like it's kind of unlimited. Even then, it's kind of limited. It's because you have a certain boundary that you're restricted to, and they can't test you outside that. How do you know when by parts will repeat? Yeah, essentially, if you have a trig. So if you have, for example, let's try it with trig, for example. It's basically by parts, but it's called the DI method. So, for example, if you had the integration of x cubed sine x, okay, normally you would do this by parts, right? E to the x sine x. I'll do that in a sec. I know what that is, bro. E to the sine, if you have x cubed sine x, right? What happens with this is, well, it's going to be integration by parts as well, but you can use DI method. X cubed, 3x squared, 6x, 6, 0. Obviously, you can see it's longer. But sine x integrates to minus cos x. Yeah, minus sine x integration. Minus that goes to cos x integration. That goes back to sine x. I'm gonna put plus, minus, plus, minus, plus. And this is a quick way of doing it if you're running out of time. Okay, that's the original question, but that's how you would apply it in terms of whether it's trig, whether it's so one of your terms should be infinitely differentiating. I'm gonna do that question you just asked me. 2025 papers. I have done it before. Let me see if I still remember it. And I'll do it on screen. Okay, if you guys want to try part B as well, try part B. And then if you get a value for A and B, definitely just put it in chat. How do you know when to use DI? So use DI if you're running out of time. But even if you want to just check it, just one of your terms will be a polynomial, essentially. Okay, that's the way you know. Because all your polynomials eventually will differentiate to 0. So if you have, for example, 3x squared plus 9, this differentiates to 6x, which goes to 6, which goes to 0. If you have x cubed plus 7, this goes to 3x squared, then 6x, then 6, then 0. You just keep on differentiating until it differentiates to 0. Whereas, in comparison to like ln x goes to 1 over x, then x to the minus x to the minus 2, and so on. You can see it's just infinite. It never actually reaches 0. So that wouldn't be considered a polynomial. Does that make sense? So only your polynomials, you do that. But I've seen some exceptions. I have seen very, very few exceptions. I think when ln x gets involved, I would if it just doesn't work with DI method, then just fall back into your parts. Okay. As your final answer, good question. As your final answer, I will show you DI. I will just do it with the same example we have here. Just quicker to write. Okay. The D is differentiating, and the I is integrating. Okay. And make sure you start with a plus, by the way. Plus, minus, and then as your final answer, it would be x squared e to the x minus 2x e to the x plus 2 e to the x plus c. Okay. That would be your final answer if you were to do it that way. Okay, Zach. I'm going to do that e to the x sine x real quick. Okay, if you guys want to try part B and tell me what you get for A and B, definitely let me know. It's rapid, innit? That's what I'm saying, it's rapid. But do it if you're running out of time, and that's why I'm saying I don't have proof that it's a valid method in comparison to integration by parts. Okay, I don't have proof of that. I will check. Actually, I don't even know where this is from, to be honest. If anyone does, show me, please. But yeah, nice, Fred. Well done. I did use it, but I always did it with integration by parts just in case. It was like one of those checking things. I think there is a 2 and 3 there. I remember there's a 2 and 3. I can't remember if it's 3x plus 2 or if it's 2x plus 3. It's one of those. I'll do it afterwards. I think it is that though. I don't even remember the integration by parts formula. Crazy. uv minus integral of u prime v. I think it's that. Okay, e to the x sin x u v prime sin x. Okay, let's do part B of this. Now, in terms of integration by substitution, Liddy's the only one you know. Yeah, that's basically the same thing. Liddy is integration by substitution. Sorry, integration by parts. It's the same thing. Like you have a formula, you get given the formula in your formula book. It's the same. Okay, part I. Use of substitution. U equals 1 minus 3x. So the first thing I kind of do whenever you have a U substitution, just get in the habit of converting it into an index form and differentiating it straight away. So you get d over dx, and this is a chain rule. We looked at chain rule last time if you were there. This is going to be a half times by minus 3. We keep inside bracket, and then we're going to reduce the power by 1. So this becomes minus 3 over 2. And that's going to be our d over dx. I'm going to write this slightly differently, so this becomes this. Well, at the beginning, we already knew that u is equal to square root of 1 minus 3x, right? So I'm just going to write this as du over dx must then equal to minus 3 over 2u. You don't have to do this straight away, but at some point you will. Okay. And then I'm going to substitute all my other stuff into my integral as well. So I have the integral of 27x divided by u. I'm going to rearrange for dx in this equation here. So this becomes 2u divided by minus 3 du is equal to dx. There we go. So I've just substituted it into there instead of writing dx. And if I go ahead and simplify this, this becomes minus 9, minus 18 even, minus 18 x du. Now we have a problem. We have a problem. We have an x and we have a du. That's an issue. So if you ever have this situation, you should always also try to convert to x. How did I convert for dx so quick? Essentially, I've just multiplied by du times divided by minus 3 and then move the dx to the right hand side. I'll show you what I essentially did. Yes, it is MC. Yes, it is. I'll show you what I did real quick. So this is going to be 2u du over dx is equal to minus 3. Okay, I've just times by dx, so dx comes here. Minus 3 divide, that goes there. That's essentially what I did. Okay, I hope that makes sense. Okay, where were we? Okay, we had this issue here in terms of the x. So, as well, you should probably try to convert this or you should probably try to make a formula in terms of x as well. So I'm going to do u squared is equal to 1 minus 3x. So that u minus 1 over 3, oh, sorry, u squared minus 1 over 3 is equal to x. Okay. Now able to substitute this into here. And this should be an equal sign, not a minus. This should be equals. So this is going to be equal to the integral of minus 18. How did I simplify to minus 18? I did 27 divided by minus 3, which is minus 9 on the numerator, times by 2. Just plug this into your calculator. 27 times by 2 divided by minus 3. That should just give you minus 18. Okay, and I'm going to substitute this term that we just made now into here. And if you have any questions, please do ask. I'm going to look on TikTok as well. Alright, cool. And then you can see the minus 18 gets divided by 3. Yes, Mustafa, send it in the chat. In Discord. This is the link. There we go. Just join that and send me it there. And this becomes the integral of minus 6 u squared minus 1 du. This is the same thing as minus 6 u squared plus 6. That's the integral of that. I'm just going to check have I done anything wrong. Rico is looking good, yeah? And that should be the following. Plus c. But, as you can see, the original question wants it in terms of x. Cool. I'm going to factorize the u out of this, just because of the way it wants. The original question said u is equal to 1 minus 3x. That was our substitution. So I'm going to factorize that u. Let's factorize that u in 2u. So this becomes u squared minus u squared plus 6. I'm going to even write it like this, 6 minus u squared. So this is going to be the following. 2 square root of 1 minus 3x times by 6 minus, because this becomes squared. This will just be 1 minus 3x like so. 3. Oh, sorry. That should be 3. That is 3. Oops. That's my bad. Yep. That becomes 2 over 1 minus 3x. 3 minus 1, which becomes 2, plus 3x. So that's going to be 3x plus 2. There we go. Why is x not 1 minus u? Good question. Why is it not? Yep, that is a very good question. Yep, you're right. 1 minus u squared. That should be 1 minus u squared. Yep, absolutely right. So that becomes minus 6 This will be minus 6. That will be positive u squared. That will be positive. That will be negative. That will be positive. That will be negative. That's positive. That's negative. So you get. Ooh, that doesn't look right to me. No, I don't like that. One second. One second. Let me look back. One second. Something's gone wrong. U squared equals 1 minus 3x, right? Yep. 1 minus u squared over minus 3. It's because you divide by the minus. You divide by the minus, that's why. Sorry. Yeah, it is that. So it's 1 minus u squared over 3 is equal to x. It's because if you go ahead and have this, I'll show you real quick. I'll move the 3x to the right hand side. 3x is equal to 1 minus u squared. So x is equal to 1 minus u squared over 3. So that changes this. That becomes positive. That's negative. It's same as before. And this will be plus. Oh, I've messed it up somewhere. I've messed up my working. Oh shit, bro. You're all good, but you need to factor out minus 2 then plus 2. No, it's because I've changed the minus. I've confused myself. Sorry guys. Let me see. Let me just quickly fix this. 1 second. Minus 6 plus 6u squared. Integrate, that becomes 6u 2u cubed. That should be minus. That's gonna be a 2. That's u squared minus 3. So I'm going to put minus 3 in front of that. That's going to be a 3x minus 2. Something's gone wrong. Something has really gone wrong, and I'm pissed now. I was actually cooking there. U squared. Let me look. Something's gone wrong. It's not 3x plus 2. Both are positive. I know both are positive. That's the thing. 3x goes to the right. 1 minus u squared over 3 equals x. Yep. We rearrange. Substitute in. That's calm. That divides. Minus 18 times by 3 gives you minus 6. That gives you minus 6 plus 6u squared. Cool. Integrate. That becomes minus 6u. This becomes u cubed. That comes. Yep. 2u factorize out. Calm. I mean, yeah, you can make your own question if you want, but just check in terms of if it's right. Maybe use Wolfram or something. And my special, should it be 54 instead of minus 6? No, it's not. It's not 54. Yeah, because you're doing minus 18 divided by 3. Bean. It is that. I'm just trying to see where I went wrong. Minus 6 times by positive u squared gives you that. I've done something wrong, but I can't see where, and I'm tempted to start again, but I don't want to start again. And that gives you that. Check the question. The question is fine. It's when I had it. Start. You want to start again? Okay, let's start again. I've done it right. I don't want to trust myself, bro. Can't you multiply it up by 3? How can you divide? It's because you factorize out the 2, right? One second. I'm gonna quickly do this again. Let me see. I'll rush through this. One second. I'll get it back to the stage where it's correct. 1 second. 1 minus u squared 3x, yep. 1 minus u squared over 3 all over u du over minus 3 du. Let's give you the following integral of, that cancels out. So we have 27 over 3, that's going to give you minus u squared over minus 3 du. That's the same thing as, that's 9. That's definitely not right. That is 100% not right. Du over minus 3 du. One second. Oh, bro. Thing is, it's not even a bad question. It's not a bad question, and I think it's being more overcomplicated than it needs to be. X is there. Yep. 27 divided by 3 is 9, right? I forgot about the 2 there. Oops. Forgot about the 2. Okay, that's fine. So that becomes a 6. Yep, that's cool. That's the integral of minus 6 plus 6u squared du. That becomes a following of minus 6u plus u cubed 2u cubed. And then I'm just going to rewrite the following like this. I'm going to factorize at the u, 2u even, u squared minus 3. Okay. That's going to be 2, 1 minus 3x, 1 minus 3x minus 3. Fairs. It's going to be the same answer, to be honest. Which is going to be 1 minus u squared. Minus 6u, u cubed, 2u factorized out, u squared minus 3. I'm not sure. It just doesn't feel right to me. It just doesn't. Like I'm getting this answer, but it just doesn't look right. Instead of taking a factor out of 2, isn't it supposed to be negative 2? Alright. Now we did u squared, because u squared is equal to this, right? So we got 1. Let me check this from here as well, because there might be something that's gone wrong here, but I'm pretty confident this is good. Minus 3 over 2, this is square root, so it's going to be u in the denominator. Rearrange for dx, we have 2u here, du divided by minus 3 gives you dx. Cool. I'm going to sub everything in, so this gives us 27x over u, times by our rearranging thing. Rearrange u squared, but I can't even do simple rearranging, well, that's what's pissing me off. 1 minus u squared is equal to 3x divided by 3 gives you that, that's calm. Substitute that in, the u's cancel out. 27 times by 2, which is 54, divided by minus 3 gives you 6, or it should be minus 6, which is here. And that's that. Expand out, that gives you this. Integrate, that gives you this. Factorize out, that gives you this. 2u cubed minus 6u, and that's the same thing as this. I'm thinking it's alright. I think it's alright. Oh yeah. Look. You factorize the minus 2 out. Yeah. It's all good. It's all good, guys. Maybe you should trust in your maths. Where's it gone? Here. Maybe you should trust in your maths sometimes. There we go. No, you're right. Yeah. Factorize that minus 2. But still. Yeah, you're right, M. Absolutely right, M. Yeah, at least it was right. Okay, Mustafa, I'm checking, bro. Alright, where do you send this? Are you deleted user? Is that you? Oh, I forgot the plus C. Can't forget the plus C. And you sneeze. You want me to do this? To be honest, that we could. Is it this question you sent me? Let me make a new page, otherwise it might crash again. Are you talking about this? Or are you talking about something else? Huh? Go back to the working out. Nah, I'm confident that's right. It's because of the minus. I didn't factorize the minus. You want me to do that question? I don't think it's that bad, to be honest, though. Which part, Rico? It's cool, it's cool. This, by the way, this is times by 2 there, by the way. That's times by 2. That's times by 2, that's times by 2. Yeah, that gives you minus 6. Divided by minus 3. Because Rico, 54, which is 27 times 2. Divided by minus 54 divided by minus 3. Oh well, one sec. 27 divided by 3 times by 2 divided by minus 3. It gives you minus 6. Check it. Because you have this divided by 3 here. It gives you minus 6. You have 27, 1/3, 2, all divided by minus 3. This gives you 18. Oh, sorry, this gives you minus 6. Check that in your calculator. Because you have this. You have this one here. You have this one here. This 2 here and this minus 3. That gives you minus 6. Ah, okay. Alright, let's look at this beast of a question. Do I think this is gonna pop up? Maybe not. First thing that comes to my mind is sectors. This is the first thing that I see. And to be honest, to be able to get better with visualizing this, it's just doing more geometrical type of questions. That's the first thing I see. Okay, and then using that sector, you can actually work out these mini little sections here. So it's actually not that bad. So the first thing, that's probably what I would do. You have an equilateral triangle here. That's probably what it looks like. Equilateral triangle plus 3 of these mini sections. That's the way I would go about doing this question. Okay, let me see what information we have. It's radius r. Okay, so we have radius r from the center. So that's r. So we're using that. We need to work out what this length is. You can use cosine rule for that potentially, or maybe sine rule. You can use sine rule. I'm going to use sine rule real quick. This angle will be 30 degrees. Why is it 30 degrees? It's because of the following. It's equal. This is r. This is r. This is r. That means that these 3 lengths are constrained by the same kind of point, and kind of we're assuming the fact that it is an equilateral triangle. I know we're making that assumption, but we can make that 30, 30, 30, all of these angles, because your equilateral triangles have 60 degrees. Okay, I'm going to use sine rule, but you can use cosine rule to work out that longer length, BC. So that means that r over sine 30, I'm going to call this x, is equal to x over, well, this is going to be 60, that's going to be 120, sine 120. Sine 30 we know is root 3 over 2. No, it's a half. So it's going to be 2r over x over sine 120. Sine 120 is the same thing as root 3 over 2. So this is going to be 4r over root 3 is equal to x. Just quickly rearrange that. Okay. 4r over root 3. I know it's not rationalized, but it's alright. Okay. Now we can work out the equilateral triangle. So this is 4r over root 3. 4r over root 3. 4r over root 3. Okay. But we need to work out this section here as well. How do we work out this section? Essentially, that mini section is the same thing as your sector minus your triangle. Well, you know, for the previous question, part 1 double by parts. Yeah, it was integration by parts, yeah. For the part 1, yeah. well, we have an angle as well, but the angle is going to be 60 degrees. So that's going to be 60 degrees. We can use radians here. I'm going to switch to radians. So sine 60 is the same thing as sine pi over 3 in terms of radians. Okay, and then triangle, I'm going to use a half AB sine C. I would advise you use a half AB sine C. So this becomes, if we substitute everything in, well, this is actually R even, so I'm going to call this, no, it's not R, I take that back. 4 R over root 3, and then this is just R. Is it R? No, it's not, it's also 4 R over root 3. Okay, that's fine, that'll do. Okay, and we'll substitute everything in to work out the mini section. Okay, so what happens is a half times by 16r squared over 3, that's my denominator, that's my r squared, times by my theta, well, it's technically not 60, we want it in radians, so this is going to be pi over 3, minus the following, a half AB, this should be there, which is going to be, again, the same thing, 16r squared over 3 sine 60, which is going to be sine pi over 3. You can factorize this out if you want, and you probably will see it sometimes written like this. I know Zara last time was telling you about this, theta minus sine theta. You could probably do it like this, and that's exactly the same thing, which would be the following, if we simplify this, 8r squared over 3 pi over 3 minus sine pi over 3, and that's the same thing as, if you put that into your calculator, sine pi over 3 is the same thing as, does it want it as a, okay, sine 60, so 180 degrees equals pi, 60 degrees equals pi over 3. It's the sine pi of, that's why. Oops, I'm in degrees. My bad. So that's going to be pi over 3 minus root 3 over 2. There we go. Of course, Zach, of course. Okay, we'll have a quick recap of what we've done. Okay, let's have a quick recap. So, let me remove all of this. We've got this shape. Connect A, B, and C together because they lie symmetrically on the circumference of the circle. And what happens is you're able to make an equilateral triangle. Okay, with that equilateral triangle, you're also able to make some sort of sectors. Okay, this sector is this region here. Okay, that's this region. However, to work out the whole area, we cannot just use a sector. We have to work out these little mini sections here. How can you do that? So you work out the sector and the triangle. So we use the area of the triangle here. We use the area of the sector here, and we essentially subtract to work out the mini section. Sector, oops, don't know why that's happened. Sector minus the area of the triangle will leave you with one of the mini sections. Do you agree? If you have one of the mini sections and you want to work out the whole thing, well, the whole thing is the triangle in the middle and the 3 mini sections on the outside. Okay, so that's essentially what we're doing as a little summary. Okay, one of the mini sections is, this is just 1 equals 1 section. This is the area of the triangle. How do you work out triangle lengths? I use sine rule to work out the triangle length. So this is R and this is R. To work out this outer length, you can use cosine rule if you really want, or if you can use sine rule. I use sine rule here just to make it a bit more quicker, but you can use cosine rule. Mini sections are equal because they lie symmetrically. But I haven't got the full answer yet. It's not done yet. It's not done yet. Now this is one section. We need to multiply by 3, so this becomes 24r squared over 3 pi over 3 root 3 over 2. The triangle question, the triangle area would be this, and we would subtract, or we would add these together. So this is going to be 8r squared over 3 root 3 over 2 plus that. Okay. By the way, Mustafa, you're going to have r in there. You're 100% going to have r in there at some point. Or you probably factorize that out, that's why. Okay. And then that becomes the following. If they factorize an r out, so this just become r squared. 24 over 3 plus 8 over 3. I don't know what that is. 24 plus 8. 32 over 3. Plus pi over 3. Let me just double check this. Just thinking about how to factorize this out. That's not right. That's not right at all. That's wrong. That's wrong. That's wrong. Let me expand this out. A root 3. No, r squared. What can you multiply by r squared to get this? That's 8 root 3 times by root 3 over 2. Okay. What can you multiply by r squared to get that? That's going to be 24 over 3 pi over 3 minus root 3 over 2. I'm going to continue to simplify this. This becomes 4 root 3 over 3 plus 24 over 9 pi minus 24 root 3 over 12 root 3 over 3, which is just 4 root 3. And then if you factorize this even more, this becomes the following: 24 over 9 pi r squared on the outside, 4 root 3 minus, so that's minus on the outside already, plus 4 root 3 over 3 gives you minus 8 root 3 over 3. I'm reading TikTok comments like here and there, but more it's on YouTube. Come on YouTube. Okay, I will scroll back up. This is the original question. I will clear out the question if you want to take a screenshot of it. Oops, that's everything cleared out. One sec. Okay, there we go. If you want more questions like these, look on GCSE even, and Maths actually has quite a few, but they don't really look at radians much in GCSE. Look at Maths, the higher level, more papers. Yeah, you have 3 codes. Yeah, you do. So we took account of that essentially. So we worked out one of the sections here. So we did sector. We did one of the sectors minus one of the triangle in the middle to work out the mini section. Okay, which is this. And to be fair, I kind of copied this across. Let me bring this back. Which is this. Yeah, we do times by 3. So here, look, once we work out one of the mini sections here, we end up timesing by 3 to get this. And we just worked out the mini sections, so we do times by 3 and add the triangle. So this is the triangle that we have. This is the triangle formula: half AB sine C plus the 3 sections. Look in the if you look like after paper M, you'll find them. And then essentially it's just going ahead and simplifying this, and this is what I've got, but I might have made some sort of mistake. So I'm just kind of double checking at the same time as I'm explaining. That gives you 8r squared over 3. Actually no, that's fine. Half. Yeah, 8r squared over 3. Theta, which is pi over 3 minus root 3 over 2, which is sine theta. Yeah, it is stingy. It's 100%. It's going to be 8r squared over 3. That's going to be 4r squared root 3. 4r squared root 3. Yeah, that's fine. That's the same as that. And then that's going to be 24 over 3. Yeah, that looks good to me. Just N. N for November, M for mustache. Either just go ahead, just look at any of those. Like they're all very good. They're all very helpful in my opinion. Okay, I'm gonna find a harmonics question. We're gonna finish off with one of those. Ooh, 1 second. I think Shri sent me this a while back. Shri, are you still here? She might have gone. Let me go through this. Let's look at this one. Oh yes, Shri. Okay. This is what you sent. This is from an international paper apparently. I'm gonna have a quick go with. Well, I'm gonna just have a quick think about this. Oh, I have seen this paper. I have seen this question. Is this from AS? This is from a C2. It's from a C2. It's not as bad as it looks. Trust me, it's not as bad as it looks. Pure 4, is it? Okay, alright, fair. That also works. It's calm, it's calm. Okay, I'm gonna do part A real quick. Part A is light. Actually, should I do part A? Yo, you guys can do part A. That's not bad. Part B. Okay. First thing what I would do actually is actually just sum in the numbers. If you have any sort of substitution like this, right? I'm gonna cross out A. If you ever have any sort of like summations like this, sub in the numbers. So it's told you that you have a sigma, you have a summation from r equals 1 to r equals 2, and essentially you're working y equals a. So I'm just thinking, do we need? I don't think we probably need pi for this. So I'm gonna keep that crossed out. Okay, r equals 1 to log a y to the r. Let's just work this out. Okay, if we work this out, this gives us the following: log a y to the 1 plus log a y squared. Let's simplify this. This is going to be the same thing as log a y plus, I'm going to move the power down, so this becomes log 2 log a y, which is 3 log a y. Cool? So this here, yes, 100%. Did you send me on Instagram? Or let me have a look. One second. You might have sent me on Instagram. Or if you're on the Discord already, that works. That works. Yeah, perfect. Yes, that's perfect. Alright, I'm gonna change the numbers on that actually, because I know a lot of people have actually done this question. I'll change the numbers on that. Okay. So this part here, can't really see the highlighter very well when it's green. This part here is going to be equal to 3 log a y. Cool. Now this one here will do the same thing. We've got r equals 1. Should I do that below? I'm going to do that below. The sum of, gonna read the send it, I don't mind. R equals 1 to log a y all to the power of r. Okay, and that's that. Okay, this is equal to log a y to the power of 1, which is just the same, plus log a y squared. Now remember, when you have something like this, when you have the whole log, you cannot move the power down. You cannot do that. This is not the same as 2 log a y. It is not the same. Okay, these two are not the same thing. Because it is the whole log function that's being squared, you cannot move the power down. So the only thing we can do is essentially just leave it like this. Okay. Next, the question is basically saying this is equal to this, and we're kind of solving for something basically. So the question is basically asking us, rearrange this in a way where it looks nice. Now, yes, Mayulu, it's quadratic. I'm gonna make a quick substitution, so I'm just gonna call this u. Okay, so I'm gonna say 3u is equal to u plus u squared. So that means that u minus 2u is equal to 0. So factorize out u, like so. U equals 0, u equals 2. Therefore, log ay is equal to 0, log ay is equal to 2, and we can go ahead and solve. Well, when something is 0, when a power is, or when a log or a ln or anything in those kind of terms is equal to 0, essentially this means that y has to equal to 1. Actually, no, sorry, sorry. That's wrong. It's... No, I take that back. It is. Y would be equal to 1. Because essentially, log of 1, log base anything of 1 is always going to be equal to 0. Yeah. That's one of our solutions. The other solution, we're going to a to the power of, so y is equal to a squared. The question is asking, find y in terms of a, so this is not a valid answer. This would be your final answer. Nice. Guys are really testing my maths though. Just keeping my maths on top of it. A squared. Oh, 1. Cool. Can you see the question again? 100%. That's the original question. Lol gamer. A to the power of 0. You could. I guess so. I mean, yeah, fair. Why did we add? The reason why we added Yud Kimi. So I'm having really delayed responses on TikToks, just because I'm on YouTube. So just comment to YouTube. It's because it's summation here, right? It's summation, so we have to add the different terms. That's why. Okay. All right. Let me look through this. I'm gonna quickly go over this. I'm not gonna do the geometric part of that question, but what I'm gonna do is this part up here, and I'm gonna change the numbers real quick because it comes up quite a lot, and I feel like it is actually, in my opinion, it's 3 marks. It is actually 3 marks. Be confident in terms of being able to do this. Julie, that was from an international paper. Nah, I missed you tease yesterday, bro. Nah, not today, man. I'm actually going to be too fat. You know how much I spent? I spent like £30 on food there, man. I got a big box. I got a milkshake. I got a drink. It's nice. I think that was £20. No, 25. That was nice. It was banging. Yeah. I have to celebrate the win, you get me? Anyways, easy. In terms of working out in the r cos, make sure you have the identities with you. This is the same thing as r cos theta, r cos alpha, plus r sine theta, r sine alpha. Sorry, just sine alpha. Okay. To get the r value, r is just your coefficients squared and square rooted. You're doing Pythagoras on that. So 4 squared plus squared square root, and whatever that is, root 52. You don't get marks for what? It depends. Is if you're trying to work out alpha, I think it's helpful. The tan of the second integer over the first. Now I agree. I do agree. I think it just helps for the guys that are sometimes who do struggle with this. But yeah, the other one is tan. You're absolutely right though, Rico. You are right. But I think it just helps people spot it sometimes, because you can have r cos alpha, because this part here, you can see what's the difference between this and this. Well, you can see the cos theta bit is the same. What else do we have different, which is 4? So that means that r cos alpha has to equal to 4. Do the same thing here. That means that r sine alpha has to equal to 6. And that's what Rico's talking about. So that means that tan alpha must be equal to sine alpha over cos alpha, which is the same thing as 6 over 4. And then we're going to do the inverse tan, which in this case, I'm just going to give in terms of radians, which will be 0.98 in radians. Okay, so your final would be written like the following: cos of x minus 0.98. What if it was 4 sine theta plus 6 cos theta? Yeah, exactly same thing. Okay. Cool. Geometric. You want me to do the geometric bit? Okay, fine. Let's do that. Let's do that. It's not that bad, to be honest. First three terms of an arithmetic sequence. Well, it's not even geometric, it's arithmetic. So it's just sine plus sine x plus sine x. Find the exact minimum value. Okay, I think this is actually a good one. Let's look at this one. Find the exact minimum value of S9. Well, if you have cos x, and actually it's going to be linked. It's going to be actually very linked to this. I'm going to bring back the original question. It was 2 cos theta plus 8 sine theta. Let's see what. Let's wing it. Let's see what happens. S9 is going to be the same thing. You can use your formula if you want, but in this case, actually no, you should probably use your formula. N over 2, 2a plus n minus 1d. Okay, and you also have your other formula, which is Sn equals n over 2 a plus l. This one's used less commonly. Okay, if we sub in 9, because that's our amount of terms, and we know our difference is just sine x, so that's going to be 9 over 2 cos x plus 8 sine x, and this was kind of linked to the original question up here. So we kind of have to do r cos theta. Can someone work out r cos theta of this real quick? In this form. Let me do it. 64 plus 4. That's going to be root 68. Tan minus 1 or 4. That gives you 1.3. Is it in degrees? It is in degrees. 1.33. Just someone check that, please. If that's correct. 2 cos theta plus 8 sin theta. I just did that really quick. 75.96 in degrees. Okay, that looks good, I think. Because pi over 2 is near there. Okay. 2 cos theta plus 6 plus 8 sin theta. Okay. Because generally, honestly, especially in Edexcel, your part A's are linked to part B's. Yeah, this is a classic question. It is quite old. That's supposed to be 9 over 2. And then this is supposed to be times by 9. No, that's fine. Okay, and then essentially we're going to put 9 over 2. And you can see this is linked to our part A, and that's why I shouldn't have changed the numbers really. But it's fine. We'll plug this into here, which is root 68 cos theta minus 1.33. Doesn't really matter if it's radians or not in this case. Okay, and this will be 9 root 68 over 2 cos of blah blah blah. Okay, well the maximum value is just going to be the coefficient in front, 9 root 68 over 2. I don't know if that R value is right or not. Let me just check that again. Square root of 8 squared plus 2 squared. Oh, fair. Okay, it's because it's 2 root 17, that's why. And that simplifies to actually 9 root 68 over 2. That simplifies to 9 root 17, which is nice. Okay, cool. Very good. What else have we got? That's some harmonic trig done. You want to look at the Ferris wheel stuff? Let me see if I can find some questions. We're going towards 5 o'clock. If you guys have more questions, just send them in the chat or in Discord. I'm looking through. Did anyone send me anything else? To be fair, Rico, I know you sent some questions before. 8 minutes. Yeah, lock in, bro. Lock in. Nah, today's session was good, bro. I liked it. It went smooth. Part C. What's going on in this one? You can never do basic maths. Oh, this was nice. This question is nice. Arib sent this in the chat. You guys just come and join, bro. You guys want to do this? Let's do this. Arib, did you do this one? Oh, fair. How do you know? You can just take the root 62 up. What do you mean root 62? Which root 62 log gamer? Are you talking about this one? I'm just trying to see what questions we got left. Actually, you know what? Root 68. It's because it's okay, I understand what you're asking for. Basically, in terms of a cos graph, right? Cos graphs have a maximum and minimum value. Okay, this is just cos x, kind of. It's basically pretend it's cos. Actually, let me fix it a bit more. That's cos x. That's cos x. Okay. Now the cos x maximum value is 1, and the cos x minimum value is -1, and that all depends on the coefficient of cos x. If cos x had a coefficient of 2, the maximum value would be 2, and the minimum value would be -2. So because this cos of whatever, it doesn't really matter. This inside bit just tells you, oh, it's moving left and right. Okay. It's just this coefficient on the outside tells you, okay, this is going to have the maximum value, and this is going to have this minimum value. So in this case, it's going to have a maximum value of 9 root 68 over 2, which does simplify to 9 root 17. Okay. Does that make sense? Yes, I'm sending it in chat. Oh, I forgot I have a lesson at 7. Oh no. One sec. Let me send the. I made it like 4 or 5 times. Oh, it's there. There we go. Let me move this out of the way. Boom. Okay. Yes. Yeah. Basically, yeah. Let me look at what you sent, Bean. You sent it in the maths channel, I'm assuming. Alright, Bean. Well, you want to do a differential equation in 8 minutes? Yeah, I'm gonna do what JBL sent me, bro. That JBL was nice. Honestly, if you have summation questions like this, first thing you need to do is just expand. Okay? Or just, yeah, expand. Show me the numbers, see what pattern you can spot. I've just put it in the chat now, Daniel. Okay. So, for this question, this is a really old question. It's a classic. What we're going to have is 3 over 4. I'm going to put in n equals 2 into this. Okay. Squared cos of 360. That's my first term when n equals 2. Okay. N equals 3. I'm going to have 3 over 4 cubed. Cos of, what's 180 times 3? That gives me 480. And I'm going to do this maybe a couple more times. Cos of 540, I think. 360, 180 times 4. It's 720 even. Times by 3. Yeah. And then n equals 5 as well. Let's do n equals 5. N equals 5, and this would give us 180 times by 5, which gives us 900. Whenever you have values like these, cos of something, cos of a number, these are just numbers. Okay, so we can try to simplify this like so. So this is the same thing as cos of 360, or cos of 360 in degrees. It's the same thing as just 1. Cos of 480 is the same thing as -1. Cos of 720 is the same thing as 1, and you'll see that there's a pattern. Well, what are we doing each time to get to the next term? Well, we're timesing by -1, and we're timesing by 3/4. So that means that our R value is 3/4, and this is a geometric series because we are adding to get to infinity. Okay, so if we're trying to work out an infinite geometric series, we're going to use this formula here, 1a over 1 minus r. Our a is just our first term, which is in this case 3 over 4 squared. Our r value is -3/4, and I used to get confused with this a lot, because they used to say, oh, make sure your r value is less than 1, and I sometimes even put just 3/4 like that. Do not do that. Just copy down whatever this is. Okay, it needs to look like that. Okay, this r absolute value just means that it needs to be a decimal number, essentially, between -1 and 1. Essentially, that's what it means. Okay, put this into your formula, put into your calculator, and you should find that this gives you 9 over 28. Amazing. Where's the answer to it? Let me see what's going on in TikTok. Yeah, and the negative will take care of themselves. Yes. Is it supposed to be 540? Maybe our maths is trash. 180 times 3, 540. But you get the gist. You get the gist though. That's supposed to be 540. Yes, it is. Okay. Cool. Can you check a 4 marker in general? Yes. Can you post it? You want to do that first bit? Oh, that 4 marker. Okay, cool. Let's do that 4 marker and then we'll finish off here. This is gonna be the last bit. Ooh. Okay. Alright. Let me have a look at this. Show that the region is given by that. Okay, so this is parametric integration. We got. Okay, so first things first is that they're given t on the y-axis. No, I take that back. 1 second. Like t is 9/4 so I feel like it's going to be linked to the y-axis in some way. What I would do is kind of work out the x coordinates potentially. Okay, well let's see. It's parametric integration. It's parametric integration 100%. First thing is because if you see any shaded area, it's probably going to be integration. Okay. When you're doing integration in terms of parametrics, if I have y equals minus t cubed over this, and I used to just find parametric, like it took me a while to get my head around, but once I got my head around it, it was good. If you have this, right, this y equals equation, what you can do is integrate both sides, but when you're integrating both sides, you have to integrate to the same respect. Yes, Zach, 100%. I think it will come up either paper 1, it's going to come up paper 1 or paper 2. But you can see that, well, we can do y dx, you can see that's generally your integration, but we can't do t and dx at the same time. But guess what, we do have a dx, well, we can make a dx from this equation. We know that x is equal to 9 minus 4t to the power of a half, so that means that dx over dt must be the same thing as a half times by minus 4. Let me scroll a bit more down. Now you guys can see, that's alright. Times by minus 4 times by 9 minus 4t to the power of minus half. I'm going to simplify this, so this becomes minus 2, 9 minus 4t to the power of minus half, and that's equal to my dx over dt. I'm going to rearrange for dx, so I'm actually just going to put dt there, and I might even clean this, make this a little bit nicer to look at, so it looks like this. Yeah, dt. Yeah, that's chain rule. Then I'm going to substitute everything in. I've got an expression now for dx. And let me, 1 second, let me put something there. There we go. Just so I can move up to the right. Then I'm just going to substitute everything in. So I get the following. Integral of minus t cubed over 9 plus 4t. Times by minus 2 over square root of 9 minus 4t dt. This is going to be the same thing as 2t cubed over square root of, now because we have 2 square roots in the denominator, we can kind of combine them together, so this becomes 81 minus 16t squared. Why? It's a difference of 2 squares. Okay, but you can expand it out manually if you want to. How would you integrate that? Good question, really good question. They've given you a substitution here, so which is potentially how you would do that. Anyways, we're going to factorize the 2 out because that's what they want on the outside. T cubed over square root of 81 minus 16t squared. And then you can put the lower limit and the upper limit. So you have 0 and 9 over 4. But you should probably technically that's not kind of proof, but that would work. You should be fine with that. Now that's fine in terms of that's okay because the t cubed and the -2 kind of fix that anyways, Arib. But let me just double check if I've done anything in terms of that. One sec. T equals 0, 904. But you're absolutely right with that. Oh, sorry, 2. 2. Sorry, 2. But yeah, you're right with that, Arib. If you take out a minus, 100%, your limits do flip. Yeah, calm. Alright, nice. Nice. Well done, guys. Good 3-hour rush for the guys who stayed from the beginning. Well done. Good luck for what is it, Thursday or Wednesday? Wednesday. You want to get the 81 minus 16. Well, you can do it like this, Bean. Square root of 9 plus 4t times by 9 minus 4t, like that, and just expand out normally. Like those are just brackets. Wednesday afternoon. Guys, smash your exam, yeah. Like the further math brothers, they ain't got anything to you, bro. Log gamer, just expand these out. This is a complete of different squares. Difference of 2 squares. So remember for GCSE, when you have something like this gives you a squared minus b squared. 81 minus 16t squared, that would give you. Yeah, relax. Enjoy. I'm planning on doing a chemistry session maybe at the end of the week. I will see. I haven't got a finalized date for it yet. But yeah. You're going to divide when you're supposed to. Probably for chem. For AQA chem it'll be, but I mean OCR guys can come. Why can't you remove the square root when you multiplied? It's because if you have, for example, it's like surds. So for example, if you have root 6 and root 7, this is the same thing as root 42 you'd. Whereas if you had root 6 times root 6, this is root 36, which is 6. You can only remove the square root if it's the same square root that you're multiplying by. In this case here it's not. It's 9 plus 40 and 9 minus 40. So we can't remove the square root. Okay, that makes sense? A bio. You want me to do bio? Bio's crazy. You guys are going to come to my bio one, yeah? And you're going to be like, yo, this guy does not know any bio. That's the thing. Nah, it's because the square roots, they're not the same long game, that's why. Stats next weekend. Alright, one more time, yeah. So when you multiply root 6 and root 7, the insides they get essentially get multiplied. Okay, and then you got root 6 and root 6. When we have the same square root, same square roots end up cancelling out. Whereas different square roots, they don't cancel out because they're different square roots, but the square roots can still combine inside. Does that make sense? Yo, you done finished, man. Finished for the day though. We did differential equations right at the beginning. I'll post a video on YouTube, and I'll clean up any of the thinking process. But yeah, surfs. yeah. Nah, but for real though, you guys did good. Smash the exam on Wednesday. And yeah, I'm gonna see if I can find it online, bro. Like on TikTok. Like I know everything is online. Yo, guys, if you're in the Discord, yeah, post it. No, don't post it. Don't post it. Alright, I'm gonna see you guys there. Yeah. Wait. You asked me to. Yeah. What about the geometric sequences, man? Well, you don't simplify till the end of the sequence. Alright. Amazing. Alright, I'll see you guys later, yeah? Bye-bye. Yo, that was unlucky, bro. Unlucky, that's actually unlucky. You can't even do anything about that. The profit ones, yeah, just keep on expanding out, and then you'll see a pattern where you can simplify with that. Yeah, I get you. So for those, I'd say make each term, so n equals 1, n equals 2, n equals 3. See if you can spot a pattern, and then identify which one it is. I know which question you're talking about, to be fair. I've seen it before. But yeah, just list it out as we did in terms of the Sigma one. Let me see if I can find it. We did the Sigma one before. I think Shri sent it. I can't remember who sent it. Yeah, this one. Like, just list out each of your individual terms and see if you can find a pattern. I know in this case it's not exactly geometric, but yeah. Alright guys, I'll see you guys in a bit. Appreciate you guys coming. Bye bye. Yo. For the guys who haven't joined yet, join Discord real quick. Join my Discord. Join my Discord. Let me post it in chat again. One more time. Boom.